Okay, I think we can start.
Yeah, we can start. Hi, everyone. And we are glad to welcome you again to the Worldwide Software Architecture Summit on Vendor Track. And Vendor Track is our so-called new experiment. So we will be happy to announce all our outstanding specialists. They will provide their expertise and knowledge of the industry, and along with that, they will share with you all latest innovations that can improve your workflow when implemented. So, and let me for sure introduce my colleague and beautiful moderator on this vendor track. Her name is Anna. Welcome, Anna.
Wow, thank you so much. And yeah, you all probably know my colleague also, Anna. She's the main organizer for this event. And I wanted to ask you, how many hours and how many maybe months have you spent to prepare such a big event? Please tell us.
Yeah, definitely. I think that it took up to 4 months for me to prepare, but thanks to my colleagues, my friends, besides our program board team and all our speakers, it was great time and I really enjoyed that. So actually it was great and no hassle, no worries, no problems. And that is why I'd like to thank you for the support, for joining us today.
Okay, thank you so much. So very soon we will be able to start. We will disappear just for a couple of minutes and I will come back to you to introduce our first speaker.
Yeah, enjoy please.
Yeah. Okay, so before I will introduce you our first speaker, I'd like to make a little announcement. Today, everyone has a chance to win a ticket to one of Geekle's upcoming events. You can choose any event you want. All you need to do is to be active in comments. You should write your questions to our speakers in the comments, and you should use a hashtag #question4ticket. And at the end of the summit, we will randomly choose 5 lucky winners, and we will provide these people with a ticket. So please don't forget to be active. Don't forget to write your comments. And yeah, be with us till the end of the summit. Okay, and now I'm ready to introduce you our first speaker. His name is Simone Pomata. He's a solutions architect at Amazon Web Services. And today's topic is containers on AWS, a journey to modern applications. Just 1 second, I will add Simone at the screen. So, hi, can you hear me?
Hi, Anna. Yes, I can hear you.
Oh, yeah, perfect. So please tell us, how are you feeling? Are you excited before your speech today?
Absolutely, yeah. I'm looking forward for this speech.
Okay. So the stage is yours. I'm disappearing from the screen. If you will need me, so please say it, and I will come back to you. And see you soon, just in 30 minutes.
Good. Thank you, Anna, for the introduction. And yes, I'm going to share my screen. So here we go. Good. I hope you can all see my screen. And I'm entering in presentation mode. And today we have a presentation on containers on AWS, a journey to modern applications. So quickly about myself. So my name is Simone Pomata, and I'm a solution architect at AWS. I've been in the company for 2.5 years, and in my role, I help customers being successful with using AWS services. I'm based in Zurich, in Switzerland, and I help customers mainly in Switzerland. And yeah, today I'm here for this presentation. So I think we can start with it. So talking about containers. So we see many enterprises moving to containers, and they choose to do this movement because of different reasons. So one of those reasons is that they want to accelerate software development. So containers are a way to package your code together with your software dependencies and libraries, and then being able to deploy it everywhere. And due to this fact, the development and the deployment can be standardized by using containers, and so this benefits the speed of developers. Also, containers allow you to build modern applications. And one of the ways they enable you is by providing a very good primitive for building microservices-based applications. Containers can be isolated one from the other, but at the same time, they can communicate one with the other. For example, if we think about an e-commerce application, we can see different functions in the e-commerce. We can see the storefront, we can see the cart, the cart, we can see the search engine, the product pages, and so on. And with the container-based applications, each container could be responsible for each of those parts of the e-commerce. And you could even write different containers with different programming languages, and then the containers would still be able to communicate via HTTP between each other. On the other side, we also see automation as a good reason why many customers are choosing containers. And containers are very well suited for CI/CD pipelines. Also, as AWS, we provide many services to help you manage those pipelines. And when talking about containers at AWS, we have a mission of being the best platform to run any kind of containerized application. And we are really working hard to make sure our customers has all the services and all the features and the stability they need to do it. And many customers are using AWS to run their container-based applications, and container-based services are among the fastest growing ones we see, with very high growth. And each week we have hundreds of millions of containers started at AWS on millions of container instances. So this can give a bit an idea about the scale that we have at AWS on the container side. And why the majority of customers are choosing AWS for containerized workloads. So here we can see some of the reasons. The first one is a deep integration with AWS. So AWS is not only container, AWS is a cloud platform that provides services across networking, security. We provide load balancing, we provide things like auto-scaling, but we also provide things like machine learning, IoT, and all of those services can integrate with each other, including container services. Another point is the DevOps workflow. So customers that decide to use containers usually need tools to make the DevOps workflow seamless. And to do that, we provide services like AWS DevTools, where you can build DevOps pipelines, or we provide tools like Cloud9. Cloud9 is our web-based IDE, where you can basically do the development, and then from there you can also kick off the deployment of your containers. And then another point is security and compliance. So AWS is the cloud provider with the most security and compliance certifications, and each of our customers will benefit from those. And we achieve those certifications to satisfy the most security sensitive customers like banks and insurances, and then each of our customers will also benefit from those. And we see many use cases being run by customers on AWS using containers. Here we can see some of them. So we can see, for example, microservices being built in multiple languages like Java, Node.js, and Go. And as I mentioned, multiple containers can use different languages and still be able to communicate one with the other. And this is very good when you have a kind of diverse development team. And then we have the possibility to do CI/CD in a very easy way. We have managed services for that. So you simply set up your CI/CD pipeline, you provide your code, and the services will do the rest. So you don't need to create a CI/CD environment yourself. You don't need to maintain it. You simply configure it and use it. And then we also see batch processing and ETL a lot. And this goes very well with the nature of containers that allow you to start and stop the containers as soon as the ETL job is complete. And with AWS, you have a pay-as-you-go model. So you don't have to provision servers in advance. You simply run your containers, and then you just pay for the time that you run those containers. We also see customers creating platform as a service stacks where they can run their application. And we see many other use cases, including artificial intelligence and machine learning, test environments, and IoT use cases. But going deeper on what AWS offers, so here we can see some of our container services, I would say the core ones. And they are divided in 3 layers. So we have the upper layer, management layer, where we have 2 services. And those services are the so-called orchestrators. So they provide APIs for you to schedule your containers. And then we have hosting services. We have EC2, which are our virtual machines, and Fargate, which is, as we will see, a serverless layer where you can run your containers without provisioning any virtual machine. And then we have the image registry. Our service here is Elastic Container Registry. And Elastic Container Registry is kind of similar to Docker Hub, but it's within your environment. So you have more control on it, and it stays closer to your cluster. And when customers need to run containers on AWS, they first need to select an orchestrator, and this could be either Elastic Container Service or Elastic Container Service for Kubernetes. And then they need to run their containers with those orchestrators, and they can host the containers either on virtual machines, or they can host their containers on Fargate, so without provisioning virtual machines. And they can also use a combination of both of those options, so EC2 and Fargate. But let's start maybe from the management layer, and let's start from the first orchestrator that we offer, which is Amazon Elastic Container Service. So Elastic Container Service is an orchestrator for containers in AWS, and we built it with one thing in mind, which is simplicity. So we want to make it simple for you to schedule your containers, to scale them, to monitor them, and to operate your containers cluster. And we want to make it easy, and also we want to make it cloud native. So ECS is built with the best practices for your container workloads to leverage the cloud native optimizations, like deploying in multiple data centers, having high availability and scaling. And all of it is really easy in ECS, also compared to other orchestrators that are available in AWS and in the market. So with ECS, you simply provide you simply provide the let's say the configuration for your containers, and then you can run your containers through the APIs provided by ECS. And one of the customers of ECS is McDonald's. They have used ECS to deploy their home delivery service, and in only 4 months they have been able to launch it. And ECS simplicity improved a lot their speed to market, as mentioned, but also the scalability and reliability, because this is built in ECS, and ECS provides you the tool for example, to deploy in multiple data centers and have load balancing across those. It also provides security because ECS is built with the security in mind, like all other services from AWS, and also it's deeply integrated with our DevOps services. So you can easily set up a DevOps environment with things like A/B testing or canary deployments, and also the possibility to automate all of it. And finally, we have monitoring. So ECS provides integration with CloudWatch, which is our service for monitoring. And this way, you can get container metrics and logs shipped in a place where you can analyze them, and you can have them in a durable way, independently from the lifetime of the container. And we see many customers other than McDonald's that are using ECS, and all they want is basically to have an easy way to manage containers at scale. But then many customers started using ECS, and they found out that other than managing containers, they were also managing virtual machines. So they had to run virtual machines, to scale virtual machines, and then run containers on top of them. And they came to us and they asked for a way to simply run the containers instead of running the virtual machines and then the containers on the virtual machines. And at AWS, we always start from the customer, from their request, and we build backward what may be useful for them. And this is the reason why we built Fargate. So Fargate is a way to run your containers without managing any virtual machine. But maybe let's just take a step back. So without Fargate, using ECS, you need to create nodes. And those nodes are virtual machines where you can schedule your containers. And on those virtual machines, AWS takes care from the hypervisor and everything down to the physical layer. But as a customer, you are still responsible for the operating system on the virtual machine and for the various agents on those virtual machines. And then you are also responsible for scheduling containers on those virtual machines. And if we have many virtual machines, it can be tricky to manage them because as a customer, you need to take care of patching and upgrading, and you also have to take care of scaling the number of instances. And one important point is that you always have to optimize, to right size and to optimize the number of instances to accommodate all the containers you need, but also to make sure that you don't waste resources. And this goes a bit beyond the simple management of containers. And many customers don't want to do it. They simply want to focus on the containers and building what really differentiates their business rather than managing all those virtual machines. And in the classical Elastic Container Service model, you have ECS to schedule containers, and then you schedule them on top of those virtual machines. But with Fargate, you don't have to care about the virtual machines anymore. Fargate will provide you with a layer of serverless compute capacity, and you simply schedule your containers on top of those virtual machines. Looking a bit more into how Fargate works, so Fargate is completely managed by AWS, so you don't have to schedule any virtual machine. You simply provide a container image, you specify the resources for the container image, and Fargate will take care of running the container for you. You don't have to run any server, and you simply pay for what you use. The service is also completely elastic, so you can set rules for auto-scaling, for example, the CPU utilization, and then Fargate will take care of running more or less container depending on resource consumptions. And you just pay for what you use, and here it means that you just pay for the resources that your containers are using. And it is different from the classical model with virtual machines, because there you had to pay for the resources you provisioned on the virtual machine, even if the containers were not fully utilizing them. So with Fargate, you get also very often a good cost efficiency. And another point is that Fargate, like traditional containers run on AWS is fully integrated with AWS services like networking, load balancing, permissions, monitoring, and so on. And a customer of Fargate, a very relevant one, is Turner. So they used to run their applications, around 850 applications, using 5,000 containers on Kubernetes. And they moved those to Fargate in order to reduce the undifferentiated heavy lifting of managing the Kubernetes cluster. And all what those customers that are looking for Fargate have in common is that they don't want to babysit their cluster. They simply want to take care about their containers and build what makes a difference for their application, rather than taking care of the undifferentiated heavy lifting of the underlying infrastructure or cluster. So Fargate really enables them to be able to manage containers at scale in the easiest way. And until now, we have talked about Elastic Container Service, or ECS, as an orchestrator, and also about AWS Fargate as an innovative way to host your containers on serverless compute. And we also see many customers that are coming from a Kubernetes environment, or that for any reason they are willing to use Kubernetes. And for those customers, we provide an orchestrator, which is Elastic Container Service for Kubernetes, also known as EKS. But maybe taking a step back, so what is Kubernetes? Kubernetes is an open source container management platform. It helps you run containers at scale, and it gives you a set of primitives and APIs to build modern applications. Kubernetes is a container orchestrator which is contributed by the community, and it's a very good choice for those customers that want to stay within the community or work on software that is community supported. And Kubernetes is having a lot of adoption, and it's been maintained by the Cloud Native Computing Foundation. But when talking about Kubernetes, once customers have chosen to use this, they also have to look for a platform where they can run their Kubernetes cluster. And for many customers, looking for this platform is one of the steps they have to go through. And what is very important for those customers in order to achieve a high level of stability for their cluster is that they choose the platform with the highest stability and with the most functionalities. And this is why most Kubernetes workloads in the cloud are running on AWS today. According to a survey by the Cloud Native Computing Foundation, more than half of those are running on AWS. And the reason why is that customers want the best platform and the more stable platform to run their container workloads. But maybe taking a look more on how EKS works, again, we should take a look at and see how Kubernetes works. So Kubernetes is basically composed by two pieces, by two components. We have the master nodes and we have the worker nodes. The master nodes is where the Kubernetes API server is deployed. And the master nodes is used by you to send API requests to schedule your containers. On the other side, the worker nodes are where you run your containers. So when you request a container to run to the master nodes, then they will get scheduled on worker nodes. And starting from master nodes, so as a customer, if you decide to self-manage the Kubernetes, you need to manage the master nodes. And if you want a highly available cluster, this is usually means that you have to deploy at least 3 master nodes on 3 virtual machines, and you have to spread them in multiple data centers. And on top of it, you have to manage etcd, which is the database used by the master nodes. And managing all of it can be challenging. And this is where EKS helps you. EKS is a managed version of Kubernetes, where the master nodes are managed by EKS. So EKS will take care of managing the nodes for you in a highly available way, and you simply get an endpoint for your cluster, and you can use this endpoint to make your API requests. And this way, the master nodes are kind of managed by EKS. And then you have the worker nodes. And the worker nodes are where, again, you run your containers. And if you use a self-managed Kubernetes cluster, you have to manage those worker nodes yourself. You have to bootstrap them, and you have to join them to the cluster. But on the other side, if you use EKS, we do provide managed nodes. And managed nodes means that you don't have to take care about the operating system. You don't have to take care about updates. You don't have to take care about patching and joining those nodes to the cluster. You simply define the type of machines you want to use, how many of them. You can define auto-scaling metrics, and then the managed nodes are managed by EKS itself. So also the master nodes are managed, and then you simply need to right size them and then to run the containers on top of them. Also, updates is something that EKS is taking care of, and this is both for the master and for the managed worker nodes. But still, this process is okay for some customers, but some customers want more. So they also want to use something like Fargate on EKS. So instead of using AWS managed worker nodes, they simply want to not have any worker node at all. They simply want to use the API server, the API endpoint, to run their containers on serverless compute capacity. And this is what we provide with AWS Fargate. So AWS Fargate, again, is a serverless layer of compute, and this can be used also in Amazon EKS. And one good feature is that Fargate will span multiple availability zones, which are basically different clusters of data centers, so that in case of issues in one of them, traffic will be redirected to the others. And so the user experience will not be affected, for example, by networking issues in one availability zone. It will be completely transparent to your clusters. So this makes it possible to use Kubernetes in a very simple way, but still using all the Kubernetes APIs, but with no need to manage any virtual machine at all. And EKS is Kubernetes certified. And this means that basically EKS can be used to run any kind of Kubernetes workload. And for these reasons, we see many customers also adopting Kubernetes on AWS. And here you can see many of those customers. And one of them, which is very relevant, is Snap. Snap is the company managing the application Snapchat, and they are running 100% on Kubernetes in the cloud. And they decided to move their core messaging architecture to AWS and to EKS. And when doing this move, they said that the undifferentiated heavy lifting is work that they just have to do, but that doesn't bring any benefit to their customers. And EKS frees up them from doing that undifferentiated heavy lifting so that they can focus on what really makes a difference for their end users. And this is bringing a better customer experience. And for Snap developers, this means focusing on deploying and developing the application rather than maintaining the cluster itself. And yeah, this was a set of services, so orchestrators, hosting services that you can use as a core to run your containers on AWS. But of course, we provide more than that. We have a vast platform of services that you can use. And in the next 3 slides, I will show other free services, which are containers related that you can use. So here we can see CloudMap, and CloudMap is a service, discovery service that works with AWS Fargate, ECS, and EKS. And this makes it easy for multiple services to discover each other. we have also app mesh. App mesh is a service mesh. This is based on the open source Envoy proxy, and you can use it again on ECS, EKS, and Fargate to allow communication between multiple containers, multiple microservices, and it will add features like observability, traffic control, canary releases, and so on. And then later on, some weeks ago at our reInvent conference, we announced AWS Proton. AWS Proton is a service that basically allows you to build pipeline to deploy core pipelines with consistent standards and management. And the problem it solves is that usually there's an interaction between infrastructure team and development teams when deploying workloads, in particular containers. And with Proton, you have clear separation of the roles. So the infrastructure operators can create standard templates for the environment and for the services. For example, they can create a standard definition of a dev environment and a standard definition for a front-end service. And on the other side, the development teams can pick those predefined environments and services, and they can write their code and they can send that code to those components. And the code will be deployed by CI/CD pipelines automatically, and also Proton will provide with monitoring so that development teams can really focus only on developing their code instead of focusing on creating the environment and creating the monitoring and logging and managing the CI/CD pipelines. And last but not least, AWS has a rich partner community. And those partners that you see here are software vendor partners on the container area. We have them collaborating with us on the foundation, on the DevOps, monitoring and logging, security and networking. And you can use services provided by those partners from the AWS Marketplace, which is a storefront of offerings from those partners of AWS that you can easily and quickly deploy in your AWS environment. And other than these, we also have a number of system integrator partners that can help you getting your project delivered on AWS. And with this, I am done with the presentation. Thank you very much for your time. And yeah, let's open time for any questions you may have.
Okay, thank you so much for your speech. And yeah, I have a couple of questions to you. Just please let me create a banner so you can read it. And
Sure.
Yeah, a banner. So do you see COVID-19 during any significant changes to the industry that might affect solution architects? Maybe some of your insights.
Mm-hmm. Yeah, so actually, I'm not, let's say, I'm just working as a solution architect, so I don't have a wide view on this, but I can say that from my personal experience, I'm still operating in a similar way than before COVID. Of course, most, if not all, of my activities are being done from home, but still, my job has remained the same. I'm still responsible for making customers successful using AWS services, and I only see this trend to continue in that sense.
Okay, I got it. Thank you so much. And yeah, another question. Do you think there will always be a need for solution architects? You know, it's such a general question, but it's quite interesting because today we have some people who maybe just started their career as solution architects and they maybe wonder, will it be popular in several decades? So maybe you could share your thoughts on it.
Mm-hmm. Yeah, also here, I've started working with AWS as a solution architect 2.5 years ago. and since that time, I've always had plenty of activities to do. In the meantime, AWS is releasing a lot of service customers being more successful also in a standalone manner. But yeah, still we continue to see a lot of activities and a lot of customers moving to the cloud, and that's the main relevant point. So we see many customers moving to the cloud, and we see a need for many solution architects to support those customers in their journey. And we do not see customer adoption as something that will fade soon. We believe at AWS that in the fullness of time, most customers will need to move to the cloud, and we already see this direction being taken by most of them, and we do not see a reversal in this trend. We just see an acceleration instead.
Okay, thank you so much. And I think that the last question for today, do you think solution architects should code even just for fun? Your opinion on it?
Yeah, so actually, as a solution architect, I can say that I'm spending a relevant amount of my time on coding. The core of my job is to work on solutions with customers, so on presenting our services, on doing architecture reviews, on doing the cost optimization sessions on customer workloads to make sure they succeed. But sometimes, I would say very often in some cases, in some periods, I also move to the coding part of things. For example, when I need to deliver a proof of concept to our customers, or when I need our customers with some examples about the code implementations with AWS.
Okay, thank you so much. And I see that we have another question for you. Just please let me ask you, are there any features to help solutions with cold start scenario for working with containers in a serverless approach?
Yeah, that's a very good question. Actually, we have our service for serverless containers, which is Fargate, and with Fargate you can start your containers without having to provision a virtual machine. So these alone will make the container startup time faster in many cases. Still, there are some cases where you need a very quick startup time for your containers. So in this case, we recommend a number of let's say techniques to use to make it faster. So one of them could be, for example, to have your container images on the ECR repository and have a private link to it. So ECR repository is a service from AWS to host your container images, and a private link is a way to access it in a private way from your network. And this can make the, let's say, the connection hopefully faster, and so the startup time will be faster. Also, what we recommend is to keep the container image as small as you can, because let's say the smaller the container image, the faster the startup time will be. And also for many customers, we see many customers that, for example, when they need to run machine learning workloads where they need a quick stop and start of the containers, or the same could be also for analytics workloads or for CI/CD pipelines run on containers. Then in those cases, we also have some projects going on that could help, and I would invite you to visit our GitHub roadmap. So on GitHub, we have our public roadmap for containers, and there you can see a lot of discussion going on around the topics like this. And I can say that this is one of the topics, and you can see a lot of recommendations from our teams and also from the community there, and also our roadmap in that sense.
Okay, thank you so much, Simone. I hope you enjoyed this time with Geekle, and I really hope to see you next time on our next events. Thank you so much. Okay, so we are going on, and right now I'm happy to make a really important announcement. Geekle is moving to a new format. Starting from today, everyone can join Geekle educational platform to get access to the recordings of all of our amazing events, both past and upcoming. So this speech and all other speeches from today's and from tomorrow's you will be able to see on our educational platform. So, of course, we also starting a new series of weekly episodes focused on different aspects of developers' growth. And here are some details on what benefits you will get by joining our community. First of all, it's a weekly online meetups with unique content from top speakers. Also, videos from past and upcoming summits by Geekle, worldwide networking with a community of more than 60,000 of developers. So please don't miss out an opportunity to receive your free trial today. I will send the link in comments so you will be able to join us there. Okay, so I think we should make a little pause just for a couple of minutes, and I will come back to you with our next speaker. Please stay tuned. Okay, I'm back. And before I will introduce you our next speaker, I'd like to make a little announcement. We are running a challenge. So you should take a picture or a video in front of the screen with the Geekle conference and then post it on social medias using hashtag that I will post in comments. And of course, you should tag Geekle's official page in Facebook, Instagram, Twitter, or LinkedIn. And then 3 posts with the most likes will be broadcasted online. So please don't choose your opportunity to show yourself to our audience. And we will be waiting for your posts. And I'm ready to introduce you our next speaker. It's Elliot Pierre. He's customer success manager at Microsoft. And today's topic is called Resolutioning Application Development with Low Code. So I see that Elliot is already here. Elliot, can you hear me? Can I add you to the screen? Yeah, I see. Okay. You should turn on your camera so we can see you.
My camera is turning on.
Oh, maybe you should reload it because we can see right now. I just can hear you. And yeah,
we will do that.
Try to turn it on again.
Okay, I know why. Oops.
Maybe you should allow your camera like an access. And when Elliot is trying to connect, please, people, our lovely people, write in comments below. Oh, yeah, cool, we can see you. Please, comments where you from, like where you from and where are you now? Why are you watching Geekle today? So Elliot, hi again. And I know that you're from France, so I would like to ask you comment ça va?
Ça va bien. I'm in France, so based in Paris.
Wow, so cool. Yeah,
so
I speak French a little bit, but yeah, that's all I remember. So yeah, how are you feeling today? How's your mood before the speech?
I'm feeling very good today. Always happy to speak about low code and how we can revolutionizing some organization, and super happy to be here with you.
Okay, so the stage is yours. I'm disappearing and I'm starting to broadcast your presentation. So go on and see you in 30 minutes.
Okay, so let's go. Okay, so again, hello everyone. So in this session, we will talk about the revolution of low code and the emergence of this new technology and way of develop application. But first, who I am. So I'm Elliot. So as I said, I'm based in France. I'm a customer success manager dedicated in France here on the Power Platform. Power Platform is the Microsoft value proposition for low code and all the platform that will brings low code for many organizations here in France. Okay, so my role as a customer success manager is to help customer and organization to develop low-code practice within the organization to transform the process. And first, I would like to have a small talk with you about what is a good idea. A good idea, it's the evaluation of a potential opportunity. It is calculated by, for example, the number of targeted customers, the frequency that a solution will be used, divided by the current available alternative. If we are speaking about low code, a current available alternative could be a traditional code development. And here, what I would like to propose to you, it's the value of a potential opportunity, and this opportunity is named low code or no code. Today's agenda, we will speak about the low code journey. Why are we talking about low code today a lot in the media and so on? We will also have a small look on the market landscape. Then we will talk about citizens developer and what is a citizens developer. And then we will also have a link with professional developers, because we will have this discussion during the session, but professional developers are also targeted by low-code. And then, of course, as I am from Microsoft, I will present to you the Power Platform and some great story that we had here in France, but also all around the world with low-code. But first, let's start with the low-code journey and the market landscape. First, as you can see, and you may know Minecraft, so this is a small quote from a young boy who was speaking with Satya Nadella, the Microsoft CEO, in 2 years or 3 years ago. And he said that Minecraft was amazing because it's like the earth, the world, and you can create your own world without having development skill. I can create my own world. So it's quite interesting to see that some young people are already using low-code to build their own world, and just reported this to Satya. But also, as you may know, only for less than 3% of the population are able to code today. This is a source from TechCrunch, and maybe we have to focusing not on this 3% of the population, and this is what we have done for the last 30 or 40 years, but maybe we could perhaps focusing on the remaining 97% of people who can code, but in low-code way. If we are talking about the low-code, no-code journey, it started around 2003, 2006 with website creation. You may know WordPress or Wix. They are today maybe the most well-known platform to creating a low-code website and to publish the website for every people all around the world. So this was the first step in the low-code, no-code journey, and it started with website. Then we had online stores, and the most well-known is Shopify. In 2006, we had people who started creating online shop with the emergence of e-commerce and start selling product by creating an online store in low-code. And today, of course, Shopify is maybe one of the most online store creation solution all around the world. Then we had Minecraft in 2009 with game creation. It's not really game creation as you will understand. It's more about creating your own world without a game. It is also the case for Roblox. This new game, maybe if you have some younger children at home, you may know Roblox. And for Minecraft, it was one of the most played game that we never saw. Then in 2010, we had business application with Airtable, who just raised more than $100 1 or 2 weeks ago, Zapier, Webflow, and it was the creation of small startup who starting develop and create something related with low code for business. Then we had the content creation platform has TikTok or Snapchat. Why we are talking about low code for this type of social media platform? This is because with TikTok or Snapchat, you can easily create a video of yourself, or you can just sing with a video and so on, and create your own content and share this content with your friends or with people all around the world. And then we had the big techs entrance. So we have Amazon with the Honeycode platform, which is the low-code platform for AWS, AppSheet from Google, and Microsoft with the Power Platform. If you have a small look on the market landscape, did you know that 500 million applications will be built in the next 5 years? This is more than all the applications that have been built in the last 40 years. In the same time, it is 5 times more faster demand for mobile apps than IT can deliver. So we have a gap here in terms of IT resources and the ask for new application. And finally, 86% of the organization have some difficulties to find technical talent to build application. So if you remember well, at the beginning of this presentation, I said that 97% of the population cannot code application. But maybe with low code, we can fill this gap together. This is the last slide with numbers. I can swear on it. I will not spread every numbers for sure, but I think that this quick question and key numbers are really useful to understand why low code matter today. As you may know, 65% of organizations have an application backlog, and sometimes many applications are not delivered because of this lack of resources and the amount of ask of new application. In the same time, and this is just amazing, 37% of organizations are still using paper for critical business process. Maybe imagine here by using paper or also Excel sheet to fulfill some information that are critical, and the percentage of error that can appear, it's just amazing. And you can imagine the time, the money, and so on that you can lose from this 37%. Then for the last two numbers, it's interesting because it is linked with the talent gap that exists today in the market. 67% of the CIOs and tech leaders said that IT skills shortage are preventing them for digital transformation and to move forward. And at the same time, 86% of organizations struggle to find technical talent to build this application, as we said previously. So here, if we have a little summary, we have a business process and critical business process that are not well structured. We have many applications asked from the business within the organization, and at the same time, not enough resources to build this application. Now, I would like to introduce you the term of citizens developers and professional developers, as we already know, I think. And then we will move after this in the Power Platform. So we can say that low code is a team sport. Why I say that? Because it will enable new way to develop application in just maybe as it is written on the slide, next year, 50% of the organization will have business and IT who will collaborate to develop technology based on innovation. So that's why low code is a team sport, because it will bring business, IT, and developers together to find a common way to develop application. Between business and developers, you have the citizens developer, more located in the business side, who will participate to develop very short application for personal use or maybe some teams use. And in the same time, you have developers and business who can work together because business may require a UX control, data integration, and so on, and they can ask to the developers for some help. In the same time, business and IT are also working together. IT professional will govern the activity for citizens dev. The goal here is to avoid shadow IT and to give to the IT all the control of the platform. And at the same time, citizens developer can ask the IT pro for training, if they can register the application within the IT infrastructure, and so on. And finally, the link between the IT professional and the developers. So the coders can create application lifecycle management, for example, based on DevOps, source control, and so on. And the IT will give access for these developers for more connectors, for more the data sources, and so on. Finally, on the left side, we have the citizens developer with a self-service approach, they will create application for their use, for the use of their team, or maybe the business unit. And on the right, the low-code project approach, like for every project, like ERP, CRM, and so on, built by a line of business users or champions, center of excellence, or pro developers. If we link this and put this in perspective with the level of complexity for every application and the number of users that will be involved in the process, we can see that the citizens developer will build application for their personal or productivity use. It will not be complex application, and in the same time, it will not target a massive number of users. They can also create application for simple business case, not super critical, but that will give them more time to do something else because the ROI will be quite interesting. Then here we are in the gap between the citizens and the local approach. And here you will have application for complex processes and data structure where the citizen developer will ask for some help to the local team. Then we have the mission critical use cases and the organization-wide initiative. These two kind of application and process will be created in a local project approach because it will involve a lot of complexity and it will also reach a massive number of users. And these two type of population have some drivers. For the citizen developer, it's the self-service. You don't have to ask for something or ask the IT to develop an application and so on. They will also learn something because by try, fail, or success, they will learn how to develop application and also understand that they can do something by themselves. And the driver for the low-code project approach, so less effort, because with low-code, if we compare with traditional development, the time to market could be lower. You can also have still the DevOps and so on capability to manage and to promote the application to everyone. You can reuse something because you can create template, then use this template, share it again, and so on. And at the end, you have something that can communicate also with your IT infrastructure and so on. And here, what I would like to share with you is an example of citizen development strategy that we saw a lot of time with many customers. So at the middle, you have the Power Platform, for example, COE. You have the citizens dev who are working with global IT and pro devs, and you have the infrastructure. And all these population are working together to develop application in a more inclusive way. Now, last section of this agenda, it's the Power Platform. So it's the low-code platform for Microsoft. And I will also share with you some great stories that we already saw with some customers. If we are talking about Microsoft's cloud, it's mandatory to speak about Azure. Azure is the Microsoft cloud with DevOps capability, database, cloud product and services, and so on. Then we also have GitHub to host and review code, to manage projects, build software, and share this with many people. And we have the business, not professional developers cloud as Microsoft 365, LinkedIn, and Dynamics 365. And in the middle of this, we have the Power Platform. Power Platform is created to develop application, automation, chatbot, and business analytics. It's the platform who will make able for everyone to develop something with a drag and drop experience like it is in PowerPoint. So this is named no code. Then we have low code to develop is with drag and drop as PowerPoint, and then put some formula as it is the case, for example, with Excel. And of course, you can still code and make some extensibility of this platform if you want to call an API, to connect with a plugin and so on. It is possible with this low-code platform. And this is why I said at the beginning of the presentation that professional developers are also concerned by this platform. Within the Power Platform at Microsoft, we have 4 solutions. The first one is Power Apps to create application in low code, mobile, tablet, desktop. We have Power Automate, who will be able to automate processes by DPA, digital process automation, where you can automate things based on trigger. And within Power Automate, we also have RPA, so robotic process automation capabilities to automate process by robot by recording the UI, like it is the case with macro on Excel. Power Virtual Agent, our solution to build bots in low code and to deploy them within Microsoft Teams or your website or Facebook. And Power BI, the business analytics platform. But the real strength of the Power Platform is that every solution are linked. For example, between Power Apps and Power Automate, you can drive business process by saying in an application, this is the first step, this is the second step, and so on, and to automate all these business steps. Between Power Apps and Power Virtual Agent, you can improve engagement with customers and employees to have an app connected with a bot to chat with people, or your customer or your partner. Between Power Virtual Agent and Power BI, you can analyze data from application or bot and so on. All this platform is also linked with some other solution. The first is Microsoft Dataverse, which is a backend as a low code where you can create table with fields, you can create business rule and so on to manage the data. You have also AI Builder, the low-code AI creation solution within the Power Platform, where you can create form processing, text recognition, object detection model, and so on. Data connectors. Data connector is key with the Power Platform because Power Platform at Microsoft, it is obviously linked with Microsoft Teams, with Azure, with Dynamics 365, but it's also linked and you can connect this platform with more than 400 connectors. For example, if you are using Salesforce or SAP or Workday, you can automate process with Power Automate. You can connect an application as a front end for your SAP expense management system. You can connect this natively with these 400 connectors. And of course, you have some management tools to help you to drive and to monitor this platform, because as we saw previously, you will open maybe this platform to every people in your organization. So as an IT, you must be able to manage this, to control, and to avoid shadow IT. So as I said, we have Power Apps, the low-code approach for building application, so you can easily create a web application, mobile application in low-code. In the same time, you can connect with more than 400 connectors. For example, as I said, SAP, Workday, Oracle, and so on. You have an enterprise governance and security approach to avoid shadow IT and to secure every application, to secure the connection with connectors, because I think that you don't want people who be able to connect Twitter and Salesforce in the same time. And you can extend this platform with no limit, because you can call API, you can connect with plugin, you can manage app cycle management with DevOps, and so on. Power BI, maybe it's the most well-known part of this platform. It's the low-code approach for self-service BI to drive a cultural data approach for everyone. Everyone will be able to have interactive dashboard to see data and to have data that is connected and who can communicate between every dashboard. Power Virtual Agents, so the low-code approach for conversation and to create bots. So you can easily create bots and share them, as I said, within Teams or within Facebook and so on, or your website. You can also here connect with the API and so on. And the last one, Power Automate, the low-code approach for automation. So you can create business process, you can use RPA, custom connector to automate some processes based on your legacy system, because I didn't say this in previously, sorry, but you can also connect the Power Platform with on-premise legacy application through Gateway. Power Platform, it's of course a platform for citizens developers, but it's also a platform for developers. What is different now for low-code for professional developers? You can connect to cloud services, you can call APIs with the Power Platform, you can use AI model and you can create how can I say in English? Sorry, I'm French. But you can also create AI model in low code and so on. And you have also the need to digitalize and capture business process to generate BI, to create AI model. So that will change your cloud delivery model to be able to also have an answer to all these needs. And the Power Platform, it's of course connected with Azure services. You can trigger another function, for example, with the Power Platform. You can use connective services, logic apps, bot. You can connect this platform with everything within Azure and to extend this platform with tools like Visual Studio, for example. So it is possible to move forward with this platform and to extend this platform with professional solution, as it is the case here with Azure, the Microsoft Cloud. And at the end, you can, for example, deploy your code and share your code within GitHub, for example. Now, as the last step for this session, what we will do is to just have an overview of some customer stories and the direct application of the Power Platform with customer. So 86% of the companies of the Fortune 500 are using the Power Platform. And as you can see, more and more companies are using the platform, as we saw 2.8 more growth for active users of the Power Platform. The first story I would like to share with you is SNCF, which is the French National Railway company. It's interesting because they created a citizen developer organization who build more than 4,000 applications today in production at SNCF. As you can see here, we created application. So this is an IT application created with ProDev and so on to manage what we call boogies. Boogies, it's the stuff just under the train to manage the maintenance of the boogie. We also have citizens developers who created application for security or also for logistic aspects. And they also created application not for business use case, but also for organization use case, as it is the case for training, to train people with Office 365 and the Power Platform. They have created all this organization of citizens development by leveraging also Office 365 tools like Yammer to create community and so on. The second example, and this is the last slides for today. So it's Schlumberger, who also created a citizen development approach. As you can see, in 1 year, they started from 0 users to more than 10,000 users today, if I remember well. They created this by hackathon. They make campaign for the COE. They created, and at the end, they created cells to empower the people to create application and to develop apps. And then now we are more in a IT adoption and development platform also. So we have The citizens, developers, and the IT can develop application today at Schlumberger. More than 10,000 monthly active users, more than 100,000 applications and 300 in production. And as you can see on the right, we have the monthly active usage of all the most well-known applications. So as you can see, many people are included in the digital transformation through low-code at Schlumberger. They created community with Yammer, but you can do this with Slack or Facebook Workspace. They created a hackathon to empower the people. They have a well-known organizational governance, but also self-service for citizens dev and empowerment to train people based on the digital sales. And at the end, as you can see, they empower the people, they train the people through hackathon all around the world. We are close to 1,000 participants to all hackathon at Schlumberger. So this is just massive in terms of citizens dev to make development available for everyone at Schlumberger. Last slide for today, the 5 focus area for the next level of low-code, because low-code is moving very fast. Enterprise trust, because many organizations don't trust low-code and the ability to avoid shadow IT and so on. One Power Platform, so this is dedicated to Power Platform, but it's the connection with Microsoft Teams, Azure, and all the other connectors. Remote work, of course, how we can build application in low-code in a remote way. Fusion team, so it's IT, citizens dev, and pro developers working more and more together. And at the end, hyper automation. Of course, here we are speaking about RPA and the ability to extend low code also with a RPA approach. So thank you for participating to this session. And I think that we have 15 minutes for Q&A now, and you can ask me every question about low code.
Okay, thank you so much. And yeah, before we start the Q&A session, I would like to make a little announcement. We'd love to see you among us at the QA Global Summit on the March 2 and 3. So either you are considering QA as a career, a move, or have already started as a QA and engineer, this event will help you to get on top of practicing QA. So you will get 2 days and 14 hours to learn how to build QA from scratch, what mistakes to avoid, and how AI can improve testing experience. So have time to register during a happy hour and get your ticket just for $30. I will add this link in the comments. And yeah, I think we can start Q&A session. So I will create banners for you, so you will be able to read these questions and answer them. So the first one, how has the COVID-19 affected your work? So please tell us a little bit more how it changed for now.
Yeah, so as a personal affection, so I'm still very young. I'm 25 years old. So as a young professional, it affects me because I love meet people, sharing with people, have sometimes to take a coffee, eat together. And in the same time, it affects me because in the customer success role, we are customer facing. So for more than 8 months today, or close to 1 year, I am in discussion with customer. I help them to transform their business, and at the same time, we never meet in face-to-face. So it's quite difficult to have a good relationship. I think not good relationship, a close relationship without seeing people. And at the same time, the ask, sorry to make a link with the low code, but the ask for COVID-19 responses have been very huge because many organizations said, how can we manage return to the office? How can we manage home office monitoring, back to work, and so on? So they ask us to help them through low code to manage this, and we saw many organizations who implemented low code rapid responses with the Power Platform, of course, at Microsoft. But I assume it is the same for Airtable, for Amazon, and so on. to have a quick response to COVID-19.
Okay, thank you so much. So, and I also have another question for you. I already asked it from our previous speaker. So, do you think there will always be a need for solution architects? Because, like it's an interesting question. Maybe you have your thoughts on it. Maybe it will be a little bit different from others. Please share it with us.
I think, yeah, because if we take the low code, today with low code, we still have architecture. We still have people who are able to manage security, to manage connectors, API. So the need for solution architect in low code, it's the answer is yeah, of course, because citizen dev are part of the development with low code. You have the IT who are here to administer the platform. Developers for some technical, very technical, deep technical ask and way of doing something. For example, connected with DevOps and so on. And you have this need for architect to make the link of all the connection. If you want to have an application that will communicate with your ERP or your CRM, how you will connect this, how you will manage authentication, how you can access a database, and so on. So the need of solution architect in the low-code world will be, of course, something that will not disappear.
Okay, thank you. And another question, what do you think are the biggest challenges for solution architects today? Maybe a top 5 challenges.
Maybe not 5 or maybe 1. So the best one, it's the thing that solution architect, it's a need in terms of development, because to have the good overview of what can be done and how it can be done. So because more and more IT infrastructure are more and more bigger, you have more and more solution, and having a good overview of this, it's key. In the same time, the ability to share with people their knowledge, because as we are in COVID-19 world, we need to be able to share this with everyone and empower everyone of what is possible or not. And also, yeah, the ability, maybe as we saw, this is something that we saw with the low-code development. We have people from the field, from the business, who never developed something and who became today a IT project owner or architect. So also maybe the ability to empower, to detect these people and bring them to the next level by sharing with them their knowledge.
Okay, thank you so much. So let me check. I think it was the last question for you for today. Thank you so much for being with us. And I hope you enjoyed this little journey.
Yeah, of course.
Okay, thank you so much. Okay, I will turn off your camera and have a nice.
Thank you,
Okay.
Anna. Thank you.
Okay, so, and I also wanted to remind you that we still have 30 minutes till the end of the happy hour ticket for the QA Global Summit. So please take a chance and buy the ticket just for $30. And yeah, I think we already have our next speaker. Okay, I will add him to the screen. Hi, Yasine, how are you doing?
Hello, everybody.
Oh, yeah. Something wrong with the sound. It's really low. Maybe you could move closer the microphone to you.
All right.
Yeah, now it's much better. Okay, so please let me introduce you. Our next speaker is Yassine El-Khali. He's cloud solution architect at Microsoft, and he's also from France. And today's topic, how to build a zero trust cloud native application on Azure. So, how are you feeling? How are you doing? Please tell us a little bit more about you. How's your COVID situation right now?
I am very good, thank you. I'm actually quite happy. This is my first experience working with you guys.
Oh.
Yes, and be happy to maybe contribute next time. A little
Well,
bit of story, maybe. Sorry, I have interrupted you.
no, it's okay. So it's your first time as a speaker, and I'm really glad that it's with us, with Geekle. So do you have a presentation, some slides maybe?
Yes, I do. Actually, I have experience as a speaker.
Oh,
So right now I'm working as a cloud solution architect for Microsoft.
yeah.
Basically, is what I help are big customers, big companies,
Mhm.
mostly in France, and I help them well through their digital transformation. Meaning, we understand their business objectives. We try to we work them with the on actual roadmap in a technology roadmap on how to achieve their objectives, and most concretely or in practice, we help them do governance, architecture, design, implementation, security, etc. So yeah, I have experience as a speaker or trainer,
Mhm.
more within like the official Microsoft or work context, working with customers for training. And today, this is my first experience like in broadcast live
Ah,
uh, in a World Architecture Summit. So yeah, really, really happy, and well, I hope you enjoy the presentation, and we good to share and to exchange later.
okay, so yeah, I'm pretty sure it will be wonderful. So please share your screen so I will be able to add it to the broadcast. And yeah, I would like to remind you that all our speeches from today and from all our upcoming and past events, you will be able to see on our new educational platform. So please click the link in comments and join us because today everyone has a chance to get a 21-day free trial. Okay, so yeah, I see your screen. You can start showing your slides and I will add it to the
All
screen.
right. What I had in mind is switching between slides and actually my portal and some code.
Okay,
Can you
I
see
can,
all of this?
yeah, we can see it. Okay, so see you soon, just like in 30 minutes. Good luck and
All right.
yeah,
Well,
hope
okay.
everything will be good. Okay.
Okay. So I just say on this link, right?
Yeah. You're sharing the screen and we can see like a broadcast studio. So you should go to your slides right now. Mm-hmm.
Okay. And you tell me when that's okay.
Yeah, perfect.
Okay.
So I'm
Actually,
just
I'm
yeah,
sorry.
yeah.
I do not have any idea if people are already joined in or if there are any questions. So please do not hesitate to help me or interrupt me. Okay.
Yeah, sure.
Right.
Actually, if we will have questions, I will ask it at the end of your speech. So just
Yes. All right. Okay.
yeah. Okay. So see you soon.
Okay. And I just wait for your go to go.
Yeah. You can start right now, please. Go on.
Yeah. Sure. Okay. All right. So thank you. So for everybody, my name is Yassine El Ghali, and cloud solution architect working for Microsoft. And I would like to share with you return of experience on how to build the zero trust cloud application on Azure. The concepts we'll be discussing are related to zero trust, so agnostic in terms of technology, and I'll show you, of course, practical examples using Microsoft Azure and some open source software, because that's my area of expertise. Okay, so what we'll be covering. First, we'll discuss what we mean by zero trust. We'll define the problem. Then we'll take a practical example, a cloud native app, which would be a web application, simply calling API and then forwarding some requests to a database. And we'll discuss what would we mean by practical implementation of serverless security within zero trust context. Okay. As you can see, all those items will be discussed, and at the end, as Anna said, we'll be having some Q&A answers. Right, just checking my time. Okay, cool. All right, so first, we will define zero trust by contrasting it with the trust traditional model of security, simply called the network or perimeter-based security. The idea is that corporate network is secured by a boundary, typically a firewall, and everything that lives within this boundary is in a safe area. So applications do not implement advanced measure of security because the context is safe. We will confront this model to today's models where corporate applications do not live within the same network or within the same perimeter, but they interact with other applications, other services, other users from other companies, from B2C world, etc. Which means that this axiom of network perimeter is not valid anymore. So since network security is not enough by itself, what we'll do is that we need to expand the security through all the aspects of the project, the application, the business. Meaning we'll add an identity security layer. And especially for the cloud native applications, we say that identity is the backbone of security, whereas network was the backbone of security before. So we'll discuss authentication, who is the user who is logged right now, what is the identity of the application that is executing some work, and what roles do they have, what access levels do they have. And of course, when we talk about security, we talk about data protection. And here we'll separate the discussion about user data protection and how to secure credentials and variables. One important aspect to mention when we talk about cloud native applications or even hybrid applications is that the responsibility is shared. The fact that you are using cloud services like Azure does not mean that you can rely all responsibility on Azure. And at the same time, since you are using managed identities, the good news is that the cloud provider already takes part of the heavy stuff or the heavy loading of security implementation, monitoring, etc., that you can rely on. So it is an important message to keep in mind that responsibility is always shared, and we'll see practical aspects of the shared responsibility. Let's just take an example. We have talked about cloud native security, but just to emphasize the fact that zero trust security or security is not related to technology. This is sample reference architecture of an IoT platform, and we can see that the vulnerability or the risk is everywhere, and that is what we mean by zero trust. Every service, every application needs to be aware of the risks that it has within its context, and then implement the necessary security measures. Okay, so now we'll take a concrete example of how to implement zero trust for a cloud native app. I have mentioned this simple example of a single page application. In our case, it's using Angular, but it doesn't matter. It is calling an API. The code is made with Node.js, so the app code of the API, and it is running on the serverless Azure called Azure Functions, which is this logo here. The database is a NoSQL database, Cosmos DB, and here you can read serverless Cosmos database because it's simply the way of hosting this database is in a serverless mode, meaning it's running on demand. That's a detail. Okay, what we will need to focus in is that we have this application, and we'll go through the different layers we have mentioned before. So, simple cloud native app in reality would actually require more resources. The Angular would be hosted on something. So in our case, we have chosen a storage account, which is publicly accessible. We have other options. There's to bear in mind that for the single page application, we have the Angular, which is part of the developer responsibility. And you have the cloud service that you are hosting your SPA on. We have the API management in the middle. Several usages for API management I see for customers, mainly for rationalizing their assets and structuring their APIs that they expose to the external service. But it has also security features, and we will mention one in our example. We have talked about the API by itself, but in order for the API to work correctly, we need to be able to monitor what's going on. So we integrate simply an app monitoring service. For Azure, it's called Application Insights. And this app monitoring is going to help us troubleshoot what's going on with the IP service and the API management as well. And we have talked about accessing the database. So the idea is that the function will not store credentials in the code because that's a vulnerability, that's a risk. It will store it in a key vault. Okay, and here I have added the logo of Terraform, simply to say that all this configuration needs to be automated with infrastructure as code. Here I have simply mentioned the Terraform because it's open source and widely used, but you can use Azure IRM, which are the infrastructure automation tool dedicated for Azure. Okay, so we have discussed about the different layers. We'll start by identity regarding apps and applications. So we'll take abstraction of Azure, resources for hosting, the storage account and the API, and we'll focus simply on the application parts. Here I have mentioned Azure AD because this slide is relative to what we need to do on Azure side. The idea is that our Angular app will be described or mimicked or proxied, different words, with an identity on Azure AD. And the same for the API. So we'll have two identities on Azure AD, one representing the web app and one representing the API. And on Azure AD, we'll say that our Angular web app requires some scope, some permission. In our case, querying the API. And the API will expose a scope or a permission. In this case, it's API query. If we had some external SaaS service, for example, or external API, for example, Microsoft Graph API, we will not to need to expose the API because it's not hosted by us. It is an external service, but we will need to request it. In our SPA code. Okay, I'll switch the portals to show you exactly what this looks like. Okay, so here I am on my Azure portal. I have several identities representing my applications. Okay, we will focus simply on this one called self-care frontend because this example I'm showing you here, I have created a dummy demo. I have called it then self-care frontend, self-care API, GraphQL, and I have the backend. Small detail. Okay, just so you can follow my example. So here I have the identity representing my SPA, and here the identity representing my API. Okay, I'll go to the API permissions, simply to show you that here I am defining what scopes, what requests I am asking for. And I have told you the example of Microsoft Graph, which is an external service. And here I am simply referencing the identity of my other API and asking for permission to call the query. Okay, this one here is the identity of the other API. I'm not going to spend so much time on this. Simply to show you that on the API side, what we do is that we expose the API, and that's the one we were talking about. Of course, here, different stuff to keep in mind is that this configuration needs also to be consent either by the user. When you pop up, you get a message saying that some application requires to read your profile. Do you agree or not? Or some admin consent. Lot to say about identity. I cannot summarize it in 5-minute discussion, but just want to show you this aspect to keep in mind. We're still talking about application and APIs identity, but on the development code side. So we still have our identities on Azure AD representing our applications that are hosted on Azure, or it doesn't matter. What we need to do on the application side, on the web app side, is still request the scope, but in the code this time. Before I have showed you how to request it on Azure AD. Here we are talking about the code, where we'll add some code for authentication and authorization with Azure AD. And I put it in red just to emphasize it. Use MSL library. At the end, I will publish this document with references to everything that I'm citing here. But keep in mind that for the development, there is an SDK that you can use, and it takes care of the heavy lifting in regards of integration with Azure AD for authentication and authorization. Okay, so the app, it's simply authenticating the user, then it's getting some identity access token from Azure AD. And before this request is made to the API, there is the API management, which is in the middle, and it can do access validation as well. And on the API side, sorry, I clicked too much. On the API side, we have talked about validating scope on Azure AD. The same thing needs to be done in terms of code, extra layer of security. Plus, we need to validate who is the user. So the identity which is asked for by the Angular and then transmitted to the backend. Here on the API side, we still need to verify who is the user and what roles he has. And the same thing on the database call. On the DB, or it doesn't matter, the backend technology, we have a data user segmentation mechanism. In our case, it's called row level security. It's simply the concept of saying that for me to access some row, meaning some data, I need to have the access right, the right permission for. And all of this is baked in the database configuration plus the Node.js API call. As we have mentioned, identities for our applications, the Angular and the Node.js, meaning representing our applications, we have the same concept for Azure services. The good news is that, or the feature you can use is that for Azure services, the identity is managed, meaning you don't need to provide by yourself a client identity or client secret to authenticate to the service as you would do for an external service, as Terraform. So when you use Terraform, you need to connect to Azure API. And how you do this, you have some identity on Azure, except that you own the credentials for this identity because the service is external to Azure. In case of services within Azure, functions, DB, Key Vault, etc., those identities, those managed identities, well, they are managed. And here I have just put an admin identity simply to showcase the different types of identities, but it all comes down to an identity stored in Azure AD. Okay, so we have discussed those categories of identities, but the concept is the same. When we talk about airbag or scope, it says this identity or what are the roles or the permissions that it has. And in our simple example, we would like the function to access some code to access some secrets in the Key Vault. We have created a policy by Terraform, meaning when we are developing the configuration code that says, I give access to managed identity of the Azure function to the Key Vault. Okay, we have talked about Azure API management policies. in the middle. Actually, policies can do lots more than GWT authentication, and I cannot spend more time on this. The main idea is that you will leverage policies for several use cases. One for GWT authentication, but you can also apply colon or throttling or rating quotas. You can also use policies for billing and for cross-domain access, for allowing requests from the domains that are external than this domain. Okay, main idea is that you will use policies in real life for more than GWT authentication, validation. And the last aspect of infrastructure and apps is networking and domain access. The simple idea here is that the user will be accessing the app on the storage and the Cosmos DB through this standard journey, which means that the storage is only the one allowed to access the API management, which is the only one authorized to access the Azure function, which is the only one authorized to access the Cosmos DB. And how we do this? Simply by networking access list on each resource. We simply put a whitelisting to say, for example, for the API management, only the IP of storage account is allowed. For the functions, only the IP of API management, which is allowed. And same thing for Cosmos DB, to only allow the IP of Azure functions. Okay, so I'll switch back to, I have a small example to show you all of these aspects where we will encounter networking and authorization. So here, this is a resource group on Azure, which where I have created my several resources. So I have the backend API, two instances, simply one for production and one for staging. I have the API. I have here an application gateway, which is the WAF in my example. Up here, I have mentioned Azure Front Door, but I have used another one. It doesn't matter. The main idea is that we need a WAF, web application firewall, to protect incoming requests. Okay, and here I have used this storage account to deploy my web application. This one, here it is. I'm gonna use it to show you those different aspects. So simply to show you that I am simply logging on my app. And here I'm using the MSAL library, which is taking care of this part of asking me for the pop-up to authenticate, etc. Okay, it has a front page and it has a profile page where I'm calling some API. And here I am not allowed, even though I have authored my code, because the admin of Azure AD did not allow me to authenticate, which comes back to the first aspect we have seen in this presentation, which means configuration of the application identities authorization on Azure AD. And so I cannot use this API because I do not have enough rights. Here, this is a dummy example where I expose the URL of my backend, so the URL of the API management. Up, just to show you. And here it's returning nothing because I have no API. Up. So here what I did is that I'll come back to the simple example. Here from my single page app, I could not get to the other functions because I don't have the right to even to authenticate from Azure AD, sorry, to use the API call. So what I'm trying to do is to go through to the Azure function because I know the URL of the API. Okay, and the answer that I have here is that the API management says I cannot pass because I do not have GWT authentication. So API management is the first layer to block me, and it's not even network blocking, it's GWT authentication. Up. I'll show you how it's done really simply. Here I am on the instance of my API management. I have my sets of APIs. And this example, I have the API interface pointing to my Azure function. Okay. Up. I have exposed to operation, and get health information is the operation that I am calling with this URI /health check. And as you can see, I get the same error that says that I cannot pass. So how is this done? Up, it comes back to API management policy. There are a lot of things to say about API management policy, but here I am applying validation of GWT token. Okay, simply through configuration. Okay, again, I will give you the links for all the configuration. My objective here is to talk more about the concepts of what you can do. Okay, so I'm removing this policy, and I get another error which says GWT must be provided. Up. So now I should not have this error from API management, but I still get the error, and this time it is from the Azure function. Well, to be exact, it's from the Node.js code hosted on the Azure function. It is validating the GWT token by itself again. Okay, and here up, I just go back to my Azure function so I can play with it, see what I can do. I have the definition of my functions, and that's the one that I was calling from the API, health check. And what I try to do is to call it directly because I have the URL, and I cannot call it outside from the API management. Up. Let's go back to the network to mention what's happened here. I tried to call the Azure function from API, and first I got GW token, then removed the policy, so I was allowed to go through the Azure function from API management, except that here I have the GWT token, and I cannot even access the Azure function from outside, from any other IP different from API management. Okay, so this was how to show you the combination of networking access and identity authorization, so you can secure your application. Okay, one other aspect I did not talk about yet is security of the communication with Cosmos DB, and this it will take another time. Sorry, up. I wanted to show you the API. Yes, okay. The code from the Azure function. Okay, the main message here is that the API, when it talks to the Cosmos DB the database, it will set some user authorization checks before. Here it's GraphQL, it doesn't matter. The main thing is that before we call the database, and we include as well some authorization role checks. And the last part of this presentation is regarding how we can provide security to secrets and credentials in Azure configuration and in Azure DevOps pipelines. So in Azure configuration, it would simply the matter of not having the value of secrets, but simply referencing some secrets which is stored in Azure Key Vault. And for this, I will show you again the Azure function. In the part of configuration, which is basically environment variables. And I'll show you the example of the Cosmos keyword. Here, this API is using Cosmos credentials as variable environment variables, and I do not have a clear value of my secret. I am having a reference to a key vault. Okay, and the same thing, the same concept will apply in Azure DevOps, which means that I have no secret in my Terraform code. Everything is stored in the key vault. And before I run my Terraform pipelines, I simply fetch the code, the secret from the key vault at execution time, at runtime, and replace Terraform variables. Here I have small example on Azure DevOps, just to show you where we are. I will go to just release pipeline. And in my pipeline, I can access variables which are defined either here on Azure DevOps, or I can also fetch variable from Key Vault. Okay, so the idea here is that when you code your infrastructure, you do not mention any secrets, you simply reference everything in the Key Vault. And when you want to create your infrastructure with Terraform, same thing, you store your credentials in Key Vault and then you call them from Azure DevOps. Okay, I have 3 minutes left. We have talked about DevOps, we'll talk about DevSecOps. The idea here is that we have mentioned all the aspects of what we need to configure on the Azure side, how to secure code, the application authentication, how to secure code your Terraform infrastructure by not putting any secrets, and by configuration of network security, airbag, etc. The last aspect is securing the code by itself. By checking again the example of secrets in the code or credentials or clear credentials, but we can look as well at some, for example, Terraform configuration that says you have created a virtual machine, but it is open on the internet, for example, or you did not encrypt your data. All those misconfigurations or vulnerabilities in the configuration can be checked when writing the code, same as you would do for application part and APIs. Then once you scan the code, you will scan the infrastructure, and you have here Azure services as well and some Azure DevOps tasks. And you can do penetration testing or automated vulnerability testing with some tools like here OWASP-Zap, which is open source. Okay, and below common, we scan the repository or in addition to scanning the code, and we have everything related to operations and monitoring classic. And it is all integrated in Azure based on the log analytics, which simply one storation of the logs. So everything is stored in one location. All the logs are stored in one location. And we have the security services and the monitoring services on top. Sorry. Last message. We have talked about this simple application, and we have taken the focus on what needs to be on the software code and the application code. We have talked about automating the delivery with Azure DevOps, with DevOps concept and DevSecOps when including security. last message is that in enterprises, the idea when to talk about automation and compliance is that several teams would be involved. And the message here is that your application, with your business application, which is sitting on the top layer, needs to be built on several layers which are handled by security teams and operation teams. So in our example, we'll start by setting up everything we need for automation, Azure DevOps, the code, and the first key vault, which holds the secrets. Then everything related to security in terms of SOC operations, Azure policies, controls on your organization, the airbag, etc., are usually handled by operation teams and security teams as well. Third layer, we did not really mention it in our example because it is full public application. Some applications need to be connected with networking with on-premise. So we're talking about networking landing zone. It needs to be considered as well. And the top layers are more related to applications, where we have, in our example, level 3, everything that is shared by business applications. API management, it could be a Kubernetes cluster. And at the top layer, we have the software development responsibility, as we can say. And the main thing is that all the heavy lifting needs to be done on the foundation layers, so that the application needs to be responsible of the meaning. So again, in our example, as a developer, taking care of the code part, authentication and authorization, sensitizing or securing your code, and relying as much as you can on the infrastructure configuration for security, as we have seen before. And I think I'm good. Yeah, okay, cool. Half an hour.
Okay, thank you so much for your speech. And I would like to remind to all of you that you will be able to see this speech and other speeches as a record on our educational platform. So don't miss a chance and subscribe today, because you will have a free trial for 3 weeks. I will show this link in comments, so you can simply go there. Okay, thank you so much. Now it's time for Q&A panel. I have some questions for you. I will create banners, so you will be able to read the question and answer it. So the first question is, what are the most important factors that I need to be aware of when creating a solution in the cloud? Do you see still as a need for local premise? If so, when? Please, your opinion on it.
Yes, the answer would be it depends. My first question would be, who are you and what should be your profile and your business? Simply what I say, and again, every context is specific. Some startups will use cloud-only applications because they don't have a legacy, and they simply have an idea building from scratch. Whereas big companies, which already have on-premises, who are using sometimes some other cloud providers, they need to be integrated with their backend system information. So in that case, I don't see an alternative to hybrid or multi-cloud infrastructures.
Okay. Yeah, go on. Sorry.
No, I hope this answers the question. And if you have a follow-up question, I'm happy.
Yeah, sure. Okay, let's go to the next question. Why cloud is not suitable for small enterprise?
I think it is suitable for small enterprise. Definitely. What I see is that small enterprise mean, again, maybe I have talked about startup, but the idea is the same. They are small, they are agile, they want to go fast. And the cloud offers, with automation and all managed services, the ability to do less work and to go faster. Plus, with the cloud, you have pay-as-you-go consumption model, which means you don't need to pay upfront your infrastructure. You pay as you go, as you consume. So my vision is that cloud is totally fit for small businesses.
Okay, thank you so much. Next question, how to make up the lack of updating knowledge of new technologies?
That's a good one. Honestly, besides staying updated, I don't see an alternative. Concrete example, certifications for Microsoft, technical certifications, they used to last 2 years. Now, I think it comes down to 6 months or 1 year, if I'm not mistaken. But the idea is that the rhythm of updating, I think it's 6 months. It's going to go faster and faster because the technology changes, or evolution is fast. So yeah, it's really hard to keep up with the knowledge, and continuous learning would be my answer.
Okay, thank you. And I think the last question for you, what is the best strategy to migrate to the cloud?
Okay. Again, several use cases. What I would recommend is to move or migrate to the cloud while modernizing your applications. Whereas I see some customers, because they have their justifications, they use what we call lift and shift, meaning they only change the host. It's not hosted on premise, it's hosted on the cloud, but the application by itself is not modernized. It's still the same legacy application with its technical debt, etc. So like my high level response would be leverage modernization and leverage all managed services. For example, machine learning, instead of doing training of your own models, you have pre-trained models that you can use, and you simply call them with an API. So it gives you extra value with less work.
Okay, thank you so much. So it was the last question for you. And thank you for being with us today. I hope you enjoyed our audience and to be with us. And I hope to see you on our next events. So have a nice day.
Thank you. I hope you enjoyed the call. Thank you.
Thank you. Okay, so before I will announce you our next speaker, please let me make a little announcement. We would love to see you among us at the React.js Case Study Festival on March 16 and 17 this year. So either you are considering React.js as a career move or upgrade of your JavaScript knowledge, or have already started as a front-end developer specializing on React.js, this event will help you to think out of the box and master the React.js practices. You will get 2 days and 14 hours in 2 time zones to learn battle-proven React.js case studies of top companies as Amazon Web Services, Facebook, Code Academy, Product Hunt, and more. So please don't miss the opportunity to buy the ticket just for $30 during our happy hour. I will send the link in comments, so you will be able to go directly there and buy a ticket. Please don't miss this chance. And okay, we are going on, and right now we have our next speaker. Okay, hi, I will add you to the screen. Can you hear me?
Yes, I can.
Oh, perfect. Okay, let me introduce you. Haik Mikanyan is our next speaker. He's a senior software engineer from PicsArt. And today he will tell us about software architecture, and he will explain us that it's simple. So you are from Armenia. Please tell us, how's your COVID situation right now? Do you have a lockdown in your country, or maybe everything is open? Maybe you could share some insights from your side.
Situation with COVID is difficult as everywhere. No, we are not locked, but we cannot visit some countries.
Okay, I got it. So I hope that this situation won't affect your today's speech, and I hope that we will enjoy it as well as you will. So are you ready to share your screen? Yeah, I see your presentation. Okay, so please, you can start. I will disappear from the screen, and I will come back to you in 30 minutes.
Thank you.
Okay.
Hello, I'm Haik Melkonyan, senior Android engineer from PicsArt. I'm here to speak about software architecture in mobile. But before, I want to tell you about our experience of moving to clean architecture, about advantages and disadvantages of clean architecture and how it works. Then I will talk generally about architecting, what to do as a software engineer. Also, I will talk a little about code design. And at the end, I will explain why the topic called It is Simple. For mobile development, we can see a lot of architecture systems. And core of all is splitting view, business logic, data. In different places, names can be different, use case, domain, repository. But the core logic is the same. Different architectures provide different ways for splitting and implementation. We will call those parts layers, and our splitting will be done by layers. Layers are the core part of software architecture. The correct definition of your layers and dependencies between them will give you the possibility to have scalable architecture and testable code. Why the layering is important and why senior staff must follow it carefully. In any other levels of development, it can be code design or some language related principles. Team lead or reviewer can find all issues during code review, but it is too hard to understand architectural problems when you review pull requests in GitHub. So you must define your architecture by defining layers and dependencies between them. And that definition must be very simple and understandable for all. And dependencies must be strict. That will help you to keep consensus between all developers. You can split your layers by logical components. For example, view, business logic, data. From business logic layer, for you visible only repository. And the repository is visible only from business logic. So nobody can directly access to your repository from view layer. What kind of benefits you have by keeping dependency inversion principles? In this case, we will use dependency inversion for connection between layers through interfaces. It will make your code scalable, easy to refactor, easy to understand, also will minimize dependencies. Every time you can change your whole implementation and all other layers will work as before. If you have unit tests in other layers, running them will be enough to understand that modules are still working correctly. By doing this all, you will get scalable architecture, which will provide you testable and modular code. Why and why you need it? By saying testable code, I am about unit tests. When your modules are independent from others, it makes it easy to write tests on it. Correct layering and correct dependencies will ensure that you don't have not testable code in layers like use case or repository. Testable code will help you in refactors. After refactor, only you need is rerun your tests. Here is one more reason how dependency inversion principle help us. Let's check this sample. Here is how our core layers looks like. And for us, use case and data layers must be testable. But our dependencies are a little different. Here how they look. There is no direct dependency between use case and data. They are connected by data interface. So all we need to do here is just mock that interface, and you can cover with unit tests all your use case module. Also, your code is modular. Your modules automatically become reusable because they don't depend on platform features or from your project. You can move it to any project only with keeping the correct interface. Look to our use case module. Suppose you want to use it in another project or even in another platform because in here you have clear Java or Kotlin code and you can move it to somewhere. It doesn't depend to your project and it doesn't depend to Android. What you need is move this module and data interface to some project. Then you can implement your data interface for that new project, and that's all. Also, your modular code makes sure that every time you can change your implementation in module without breaking anything. Look to our data module. We can just remove our data implementation and add new implementation. As you can see, it can be done without any changes in our use case and view layers. Let's check one sample to understand how this is implemented in real projects. We have simple page of sign-in or registration. What we can see in our screen is our UI. There is text fields, button, image view, data. What we see, text, image is coming from repo layer, repository layer. It can be translatable text or some specific text or image from backend. Our use case is button action, which will log in or register. Also, text fields is our use case, because in this case we need to validate text before continue. So we can split this to our layers. We clearly understand what will do each of our layers. Let's start from view. Because this sample is from Android, we have also view model, which will do view-related logical tasks and communicate with use case. How it works? View need to show some image and text. It will subscribe to view model to receive that data. View model will ask for data to use case. Use case will read it from repository. It can be cache data or API request, or can be from database. If needed, use case will make some changes and return data to view model, which will post it to subscribed view. And every operation will go to this cycle. If it is not only view related, for example, show loading. Use cases most important work here is validate email and password. After validation, do all required requests and caching using repository. Repository is a data provider. It can use file system, database, or API requests for read and write data. For those operations, we are using services. It is another layer placed under repository layer. It can be different in different platforms. It provides platform-related services or libraries or something else. Here you can see that our use case and repository are not dependent from Android and are not dependent from our project or some another modules. So they are fully testable. For the view model, also we can write tests using some libraries, but it will not be clearly unit tests. Of course, there are also problems in clean architecture and I think everywhere. And I want to share the most common problems we met in our experience. What kind of problems we have? Our architecture is for Android, so we have MVVM in our view layer. Then we have use case and repository. Also, we have service under repository. In a lot of cases, when you have simple logic on your view, your logic which is related to only view. In mobile, we have a lot of cases where logic related to only view. It can be show loading, animations, or recycler views, or another views. All that view-related logics will be done in view layer. For us, it is view model. And when your view is a little stupid and don't have any other logic, it needs just data to show. Your use case will make only transition between your view and repository without any changes. Because you cannot directly access to your repository from view, you need to write code in use case, which is unnecessary in this case, but it is required to keep up consistency. Also, to keep your modules independent from each other, you need to map your objects from data layer to another objects for use case layer by creating entities. Even sometimes you will map your entities to another objects which will fit your view better. Even if your objects in data layer can perfectly fit directly to your view, you need to do this work because you cannot allow your view to see what happens in data layer. It can be objects parsed from JSON with the keys for JSON objects, and you cannot show that to your view layer. By using clean architecture, you will write more code than before, but from some point you will start to reuse your codes, and it will make your development much faster than before. Keeping consistency is very important. Yes, you have cases when you can ignore your use case layer and read data directly from view. And for that case, it can be okay. You can use objects from a data layer, and again, it can be okay for that case. But doing it in some cases, you will allow to another developers do it in all cases, because you will open dependencies from view to data. And of course, developers are lazy. They will not use use case layer, even if they have big logic to write. They will directly access to data layer from view. So you cannot track it, and better to just keep strict dependencies. Also have to have checks in GitHub, and sometimes write more code than required to be sure that nobody can destroy your architecture. Another big problem is splitting your features. Because we have layer-based modules, in each layer we have all classes for all features. And the splitting is done only by packages. It's like folders in Android. For developers, hard to understand where the features code starting and where is the end. Also, you need to have some same packages in other layers. You need to have same package in use case, in repository, in view layer. It is hard to find all my classes. Only way to handle this is keep very strict naming, which will make it easy to see my classes. For example, if you are working in login, you must have login use case impl, login fragment, login repo impl. And by typing login, you can see all your classes, but it is hard to track, and that all developers keeping this naming, and this one is problem. Of course, this problem can be solved if you have feature-based modules, but it is different architecture, and it is another big theme to talk. The biggest question about clean architecture is, do you need to start your project from clean architecture? And there is no one answer. First case, if you are working in some small startup and you need some small application, but you need it faster, you need that product faster. In this case, it is impossible to do with clean architecture. You need, for clean architecture, you need more time. You cannot do it very fast. If you are starting a big project, or maybe a small project, but you understand that your project will grow, in this case, of course, you need architecture, some architecture. Depending on your platform, you can decide, do you need clean architecture or not? From our experience, I understand that clean architecture is good one, but I will prefer it without use case layer for Android platform. View model repository is enough for Android. But for other platforms where you don't have view model, of course, you need use case layer. And even in some Android projects where is more logical code than view related, you need use case layer too. And of course, you are free to modify that architecture systems and fit it to your project better. I think still there is no one way that can fit for every project perfectly. As promised in the beginning, I will tell you when you need to start architecting, in my opinion. When you need to start think about your architecture. The start point is when you receive your task in PRD. You must deep dive on it, and you must split that task to your architectural layers. There you can find what kind of mistakes or problems managers make. And of course, they make it every time. Finding that problems earlier, you will have chance to make more clear code. If you find it later, you will need big changes to fix it. For example, to fix some flow-related issue. You need to check if all parts have their business logic, if you can understand from where you will receive your data, if there is full flow and all possible continuations are handled. Here's some sample of PRD. What you can check in here, how to fit it in your architecture. There is a lot of data in the view. You need to understand where from reading that data. Is it just data, or you will do some changes on use case to show that? What will happen when user leaves this flow from the middle? Can you handle this navigation in all cases? Can you understand use case of this flow? Can you understand use case of each screen? When you need to show this flow to the user? And questions are a lot. For me, it is most important part before starting development to get answers to all my questions. After understanding your task, you need to split it correctly in your mind or better in paper. When you have split it, your business logic from your view and data, you can provide use case interface and entities, and you can start working parallel in all layers. Someone can start working view, someone can start working repository layer, and someone can continue implementation of your provided use case. The use case interface and entity is enough to other developers to start working in all layers. Okay, now let's go a level deeper and from architecture to code design and to code design level. As a mobile developer, it is very important to keep your code design synchronized with other mobile platforms. Also, will be good to have some level of synchronization with backend. Of course, in perfect case, you must have same architecture in all your platforms. But in that case, you will ignore a lot of useful features from your platform. For example, Android provides MVVM, but iOS provides MVC or Viper. So you need to choose one and then implement it in other platform. It will take a lot of time and development will be difficult. And a lot of platform-related parts will be impossible to change. For example, you cannot use view controller from iOS like you are using activity in Android. So we prefer to keep it in code design level. Because when you implement something, in most of cases, your application will support same feature in all platforms. And every change on it will be done in all platforms. When you have same design, it can be done. When you have differences between your platforms, one of platforms can say that it will take long time or it is impossible currently. Also, it will be useful for code sharing between platforms like libraries or C++ code. Also, other languages provide possibility to share some code, for example, currently Kotlin. And you need that synchronization also for code sharing. Here we come to the point why the topic is software architecture is simple. I'm sure that I'm not inventing something new, but for me, making architecture and code simple is one of the most important parts. Of course, architecture is not simple, because in development, there is only one way to have something beautiful and close to perfect. The way is to make it simple. With complicated architecture with hundreds of layers, you cannot explain to someone how it works. You cannot understand your dependencies graph and work with that, or how to add new classes, how to add new features. Can you understand what is in the picture? It is a complicated dependency graph from Android project. Even no need to zoom it to understand that we can't understand this. Can you work with that or explain to someone this? I think no. You must have architecture that developers from junior level can look at to project and understand who is where. And you can explain your architecture in 5 minutes. You must think a lot and do a lot to make it simple, to bring it close to something natural and realistic. Of course, it is not simple. You must do it to make it simple. The same problem we have in design and code level. A lot of developers, when they want to show that they are not just developer, but they are in some level higher, they start writing some difficult code and very complicated code that nobody can understand, but it works perfectly. So you can write code by using something that nobody in your project understands. But it is not useful. You will spend a lot of time to explain it, and after a month, even you cannot do fixes or changes there. Better to write code which is simple, no matter what is your current level. Higher level, more simple code. Development will become more harder when you think hard and write complicated code. Just stop in case when you understand, you can't remember where you have started. And rerun that process, keeping in mind, it must be as simple as possible. Again, it's very important to think a lot before you start. That's all what I want to tell. With this speech, I wanted to share my experience in architecting processes as a software engineer. Thank you for attention. I will be happy to answer to your questions.
Okay, thank you so much for your presentation. And yeah, before we start, I would like to make a little announcement. Please take a chance to win a ticket for any Geekle event. You should simply ask questions to our speakers and use a hashtag question for ticket. And then at the end of the summit, we will randomly choose 5 lucky winners, and we will offer you a ticket to any of our events. So, okay, I think I should post this hashtag in our chat so others will be able to use it. Okay, Q&A session. First of all, please tell me, how did you enjoy your speech? Did you like it?
Yes, I like it.
Okay, cool. So I will create banners for you with questions from our audience, and then you will be able to read it and to answer it. Yeah, let me please. Okay. I think it works like that. Okay, add banner. Yeah. So knowing what you know now, what would you have told yourself when you decided to become an architect? So maybe some insights from your career, your path to where are you now. Maybe some advices to those who just started their career path.
Of course, I'm not competent to answer to these questions because I'm not architect, but I'm software engineer. But I can say my opinion. You need to have big background in different languages to become an architect, and you need to understand. You need to understand how it is working in different platforms, how it is working in different languages, because architecting cannot be only for one platform. It must be for different languages and for different platforms.
Okay, thank you so much. Another question, how has the COVID-19 affected your work? Maybe something changed, or how do you work now from home, or maybe you still visit in your office?
Currently, we are working from home, but we are free to visit office. We have worked from home about 6 months, started from March last year. When we have started working from home, we have done a lot of work from home at the first period. Currently, we are working like before we worked in office. It is not affected, I think, in my work. Only we lose the meetings and face-to-face meetings, I mean, and some discussions. But we are working. Our work is okay. We continue working correctly from home.
Okay, I got it. And the last question, it will be for me directly. Maybe you could share just your story, a story of your career. How did it happen that you work with PicsArt? Maybe you could give some advices to juniors, because you know this company is really well known in the world, and many people are dreaming of becoming like just a part of your team. Maybe you could give some advices and share some knowledges that helped you to become who you are now.
Okay. It's about 5 years I'm working in PicsArt, and I started here as an intern Android developer. Currently, I'm a senior 2 Android developer, also team lead. And if you don't know, PicsArt's office directed in Armenia, the big part of PicsArt. And if someone want to continue his career in PicsArt, there is a lot of chances. There is a lot of internships and learnings. You can and open positions. To grow in your career, of course, you need to learn a lot and work a lot. I can't suggest something more. I think learning and working are the key.
Okay, thank you so much. So I think it was the last question for today. I hope that you enjoyed to be with us, and maybe we will see you on our next events. So thank you and have a nice day.
Thank you.
Okay, so before we go on, I would like to remind you that we have a challenge. You should take a picture or a video in front of the screen with Geekle conference, and then you should post it on your social medias like Twitter, Instagram, Facebook, LinkedIn, whatever. Then you should tag official Geekle's page and use our hashtags. And 3 posts which will be the most liked by your audience will be shown today to our audience of this summit. So please don't miss a chance, and let's have some fun with it. And while we're still waiting for our next speaker, I think we should take a break. You should go and make a cup of coffee for you, maybe exercise a little bit, because we still have two amazing speakers for this track. So I will disappear just for a couple of minutes, and then I will come back to you and we will go on. So see you soon. Okay, hi everyone again. We are back and we are almost ready to announce our next speaker. And before that, I would like to remind you about the challenge that you should take a photo or a video with Geekle's screen and with the conference of Geekle on your screen, and then you should post it on your social medias, Facebook, LinkedIn, Instagram, Twitter, tag Geekle's official page, and then we will choose 3 top posts and we will show it on our screens today for our audience. Okay. Let's go on. And our next speaker is already here. I'm ready to introduce him. Okay, it's Thomas. Hi, can you hear me?
Yeah, hi Anna. Yeah, I can hear you correctly.
Perfect. Okay, so Thomas Lemulek, he's solutions architect at Amazon Web Services. And today he will tell us about serverless and event-driven solution for large-scale provisioning. Okay, so how are you doing? How are you feeling before your speech? Are you excited?
Yeah, definitely. That's a super exciting topic that I've encountered more and more with my customers at AWS. So definitely interesting for many people out there. So thanks for joining me today. Yeah.
Okay, thank you so much. So please try to share your screen. I will add it to our main screen and you will be able to start. Okay, and right now, please don't forget that we also have our challenge for the most active attendees today. You should ask speakers, write your questions in comments, and then we will choose most active people and we will give you a ticket for our next event. Okay, so I see your presentation. So good luck. I'm disconnecting the screen and see you soon.
Thank you, Anna. So hi everyone again, and thanks for joining me today for this presentation. Anna introduced me quickly, but I'm Thomas Lemulek, so solutions architect working for Amazon Web Services in Germany, in Berlin. Before that position, I've been actually working more as a software engineer and also some DevOps and IoT background when I was working in Singapore and Hong Kong. And more recently, I got back in Europe like more or less 1.5 years ago, and I started to work for AWS as a solutions architect. So I'm really pleased today to talk to you about serverless and event-driven architecture. I'm guessing that if you're attending today, it's maybe because you want to create some value for your customers or enable your organization to move and innovate faster. You might be also asking yourself which technology and which serverless services might be the best for you, or what could be also just the best practices around serverless. So that's what we'll be trying to tackle today. And I've decided to demonstrate the different benefits and capabilities of this topic through a case study. So I've been building on the AWS platform this solution, this project. And in this example, you will see no servers and it will be fully automated and the capability of scaling globally. So for today's presentation, the first section, first of all, I will try to also set up, make sure we are on the same baseline, right? In terms of serverless and event-driven concept. So I will just take a moment at the beginning to talk about this. And then we will jump in the specific use case. And in the interest of time, I will not go too deep in the serverless and event-driven concept or services, but there is a lot of resources out there online. So if you want to dive deep in the capabilities, we can also discuss this in the Q&A, and I'm more than happy to also share with you some resources if you want. All right, so let's get started with the serverless concept on AWS. First of all, for those that are kind of new to the cloud and new to AWS, it's worth mentioning that with the cloud, you pay as you go, meaning you will pay only for the time you're using the resources. So for example, if you have a need for a specific server, you can launch EC2. That's the service for servers on AWS. But you can stop the machines if you don't need them, and then you will stop paying. So of course, you can launch these machines with auto-scaling configuration, so it can adapt the scale based on the traffic need. But even though there is all this automation and optimization for cost and performance possible, you still need to manage these servers, right? You need to make sure that the utilization is always high, and also make sure that you are patching for security this operating system. And that's exactly where the serverless is coming into place, because with serverless, we are meaning basically applications that are built with technologies that can eliminate the needs for managing the servers. So you don't need to patch the operating system anymore, for example. And with serverless, you can scale nearly infinitely automatically. And so you will never lose business because you cannot scale anymore. It's kind of powerful as well for that aspect. And additionally, you will also use a pay for what you value pricing model, meaning you will never have some idle resources, and you will pay resources on a runtime on a business event. And lastly, the serverless components are automatically highly available. And the reason is mostly because they are based on managed services that are taking care of the high availability by default. And a quick word on the serverless strategy for an organization or for a team. That's more or less the best way of achieving the maximum value from the cloud, because you will be building your business and not the infrastructure anymore. So it means that you will be able to reduce the time spent on things that aren't core to your business and work on features that can differentiate your product, your business from the competition. So you will be operating on business events and not on the run rate anymore. So you can start thinking really in terms of business logic and not in terms of infrastructure anymore. So it's kind of a new way also of thinking your project. In terms of services on the cloud, you might have heard of serverless through Lambda function, but actually serverless is much more than Lambda. In this slide, you can see some serverless services that are used in the case study that I will be talking about today. But there is actually much more serverless services offered on the AWS platform. We have the first layer, as you can see, the compute with Lambda first. So Lambda is kind of importing your function, importing your code or a Docker image as well. And you can trigger this code on an event. To give you an example, you can trigger your function on a new message in a queue or on a new HTTP request on an API. And you will only pay for the memory used and the time of the execution of this function. So the more optimized your code is, the more cost optimized your architecture will be. We are also giving as best practice to always try to keep a Lambda function to do only one job and to try to keep it stateless as much as possible. And the second possibility for compute is Fargate. Fargate, you will bring your container image in a container registry, and then you will basically choose the CPU, you will choose the memory needs, and then you will only pay for the time running. If we move a bit out of the compute and move to the data stores, you can see that we have S3. You might know S3 as well. It's the commonly and popular object storage from AWS. So you can store CSV, JSON, PDF, or any type of images, or for data analytics as well. It could be useful. So S3, you don't need to think also about the infrastructure to store and to scale that is managed. For the databases, I put here the Amazon DynamoDB, which is the NoSQL serverless database that could also scale based on the numbers of requests or based on the storage needs. But now that we've seen all these services, right, that are kind of isolated from each other, decoupled, how do actually all these services communicate and send some information and messages? That's where the last layer, the integration, come into place. We have API gateway, the first one, that is kind of the serverless front door for application to access data, business logic from the backend services. So you can put an API gateway in front of AWS services and abstract all the implementation. For example, you can put a Lambda function, or you can put an EC2 if you need a full server, and that's up to you. You can also have some specific features from API gateway, such as using different versions of your API or protecting the network with some throttling, or you can also centralize all the authorization and access control in a policy, so you can also remove all this concern from the code. So you also have less effort and fewer bugs. And when I'm talking with customers about their different microservices architecture on AWS, and more specifically about the communication landscape, right, for these microservices, they talk a lot about APIs, but not so much about asynchronous messaging. And that's an important point here because synchronous systems, for example, through an API, are tightly coupled. The problem that can happen in downstream dependencies will have a direct impact on the upstream callers, right? So for example, if you have API gateway that is triggering a Lambda function synchronously, the API gateway will be blocking and waiting from the response from Lambda. While with an asynchronous message, it will be more in the form of a fire and forget. So the producer and the consumer will be abstracted, so it will improve the resiliency and reduce the dependencies as well. And that's where actually Amazon Event Bridge and Amazon SQS are coming into place. They are two asynchronous messaging service that can support event-driven architecture to improve the resiliency, availability, and scalability of your application. So the SQS, Amazon SQS, is the Amazon Simple Queue service. That's a scalable, durable message queue. You can persist your messages up to 14 days, and really you can put more or less any volume of messages and at any rate. And for Event Bridge, that's the Serverless Event Bus service. So that will help you to ingest and route events from SaaS application as well as AWS services, or also your own custom system. We'll see what could be the benefit in the use case. And it's more or less offering you an endpoint in which the producer can send some events, and then the router will be managing, directing, and filtering the different events to the appropriate consumer. So that way, the producer and the consumer will be really decoupled. So let's now jump in the case study. We've been setting up the kind of the baseline for event-driven architecture and serverless, talking about some of the services. Now let's introduce the elastic provisioning. That is the specific use case. That is a platform that helps the manufacturers to provision industrial devices at scale, leveraging the AWS cloud. I've been working on this project because that's a common challenge actually for customers in the manufacturing field, provisioning at scale. And serverless is actually an interesting approach and a really good fit for such use case. So I found it also interesting from an audience perspective, right, to see how serverless could be applied for, let's say, large-scale project. So in this case study, I will just spend 5 minutes at the beginning to state a bit the problem, explain the situation, and how everything worked at a high level. And then we will get a bit deeper into the architecture, the backend architecture with the serverless features. So to start, let me introduce you the concept of provisioning to give you a bit of context on the project, right? We are here talking about deploying a set of software on a specific device, on a specific hardware. That could be, in the case of the industrial factory, an industrial gateway, or it could be also a server within a factory. So this device could be connected to a fleet of IoT devices or sensors. And the only kind of requirements or assumptions that we are doing is that this server will have an operating system, and it will be able to communicate with one specific service, the system manager service. So what is the system manager, or as you can read on the slide, SSM? That's a service that helps you to manage safely and operate at scale resources running in the cloud as well as on-premise. So it's kind of a great service to manage the hybrid environment through a single interface. So you will be able to see all the devices or all the servers that are registered on your AWS account and in your data center or on-premise. And that's why it's used in this project, because we are really looking for an hybrid environment. The only reason or the only requirements here is that the server can run a lightweight agent, because this lightweight agent will be the one initiating the connection from the device to the cloud. so we can retrieve some information and provision this device. Let's get started with the existing landscape to solve this provisioning, at scale problem, because of course there is some solution already out there. If we take the example of a customer, let's say super factory customer, trying to manufacture 3,000 devices and trying to ship them and provision them in 3 different locations in the world. As you can imagine, this process is not something that we will do in a few days. It might take a few weeks or a few months. And facing this situation, super factory might be doing some provisioning on site. So they would be sending some technician to connect the device that have been just shipping, and then provisioning the device with a set of software. But as you can imagine, especially if it takes a few months, it costs a lot of money to send someone on site. It costs a lot of time, and you also need someone skilled with the specific knowledge in terms of software or hardware. And also, it's absolutely not scalable, right? It's not a scalable way of tackling this problem. And last but not least, if you also have such manual process in place with human interaction, this is also error prone. So you have also some automation possibility, for example, using a PXE server next to your factory. That is basically a server that will provision your devices when it's connecting to the network with DHCP. But it's also really complex to manage all the servers worldwide, because you will need more or less one server in each location, and it's a single point of failure. So if the server is failing, you cannot provision anymore. And it costs a lot of money as well to manage. So to this problem, to this challenge of provisioning at scale, there is also other alternatives. The remote provisioning with the industry standard Ansible. So Ansible, if you don't know about it, that's based on the SSH connectivity. So you need SSH credentials, for example, the SSH keys. And it's also based on the concept of playbooks. So the playbooks are a YAML file that is describing which set of software need to be installed on the device. So for example, you can think about installing Apache Web Server or any type of software, right? Kubernetes or just Docker. And Ansible is a really powerful tool, and it's a great solution, but it's still showing some limits for large-scale provisioning for an organization. And if we take the example of Super Factory again, if they want to do this remote provisioning, they have the 3,000 units. It takes a few months, best case few weeks, but that will probably be more few months. It means that you always need someone that will be available to provision remotely on demand these devices. That's not really realistic, right? To have always someone that will be connecting remotely to provision one by one all these instances. And on top of that, you also have some security gaps, because it means that the SSH credentials or the SSH keys will be also located on the machine of the end user, the one that is connecting remotely. So there is really a gap in terms of security, automation, availability, right? Because also if this person is sick, what do? You cannot provision anymore. You could also have, if you want to make it, let's say, more automatic, you could have some servers always running for the time of the let's say, manufacturing to shipment to provisioning. Let's say it takes a few months. You can have these servers running up and running in different locations in the world with some automation script to connect to the machine remotely with Ansible. That's fine, but it costs a lot of money to have these machines idle most of the time. So the proposed solution is basically using the cloud to support these specific challenges. And we are planning a solution. This has been a project based on a solution with a serverless architecture that is aiming to eliminate all the different limitation from the different solution we've seen before by leveraging the cloud benefits. For example, we mentioned the security gaps of storing the credentials and the security keys close to the end user. Well, with the cloud, you can store these secrets securely. For the global management, in different location, right? And the configuration at scale. This also can be supported by AWS cloud services and the global AWS infrastructure. And if you think about having a system always available during the entire shipment to provisioning pipeline, if you don't want to have idle servers running all the time and costing a lot of money, that's a big challenge. But with an event-driven architecture and serverless services, that could be solved. And that's what we will see today. So as I mentioned before, a bit earlier, one of the common approach for managing and operating these servers remotely is Ansible. So that was one of the goals of this project, was to combine the industry standard Ansible, so the customers could also use their skills in-house and combine it with AWS cloud benefit. So the availability, the serverless cost benefit, and the performance, as well as the security, the things that we mentioned just before. So now that we understood the benefits of combining Ansible and AWS cloud, we know that we want to do this. The question is, how do we actually connect the on-premise devices to the cloud in a secure manner? Well, System Manager, as mentioned a bit earlier, is an AWS service that helps you to manage the resources in an hybrid environment. So it can enable you to have a secure SSH tunneling from the agent running on the device directly connected to the cloud. And that way you can have, for example, by leveraging this SSH tunneling, you can provision with Ansible from the cloud directly on the device. So instead of having Ansible running on the computer of a technician or of anyone, it will be running automatically in the cloud and connect to the SSM agent through the SSH tunneling. And we will see how all this process will be automated, this whole flow. Now we will dive a bit deeper in this connectivity, actually, this connectivity to the cloud. And for this, the first important concept to mention is the activation. So each device that needs to be provisioned, each gateway or each server, will have a set of tags that represent this specification. You can think about, for example, on the left, you see factory, Paris, project, smart lift. That will give you all the specification about this device. And on top of this list of tags, we'll have also a license that will give the device the possibility to register as a remote instance in the cloud. So the activation is really this combination of a license and the device tags. And for this project, I've decided to simplify the process of connecting the device to the cloud by automatically generating a QR code. We will see actually how this QR code can be generated in a serverless way. And the on-site operator will be able to scan this QR code to automatically provision the device. So if we take a step back now, we need on the device the system manager agent. We need a set of tags to identify the device. We need a license to be able to register this device in the cloud. And all these requirements are embedded in the QR code. And the last important concept before getting into the implementation itself is actually an important question, right? Is how does the system know what to provision on a device? Which set of software needs to be provisioned? And that's here that comes the concept of mapping. The concept of mapping is basically a combination of the tags of the device, as I mentioned before, Factory Paris, Project Smart Lift, Team Innovation IoT, for example, with the specific set of software that needs to be installed on it. So the set of software to install is actually described through the Ansible playbook that we mentioned before. As a reminder, the Ansible playbooks are this YAML file that is describing which software to install. So for example, a mapping could describe that for each device with the tag Factory Paris and the project Smart Lift, we want to deploy a specific Apache web server on it. So the mapping association between the tags and the configuration will be made on the Elastic provisioning platform as well. So if we summarize and take a step back on this complete flow, that has been a lot of new information, a lot of concept here. We'll have the first actor, the administrator, that will be operating on the platform. They will first upload some configuration in the backend on the platform that I will be showing you just after. The configuration could be the playbooks that will be describing the software, the activation that are combining this license and the set of tags in the form of a QR code. And lastly, they can also create a mapping between the activation and the playbooks. And the on-site operator will plug the device, scan the QR code that has been generated before by the administrator, and this will install the system manager agent. It will start the remote provisioning on demand. But under the hood, what is important to mention is that this infrastructure is fully serverless. So there will be no cost or no compute resources running if no QR code is scanned, basically. That's something important to realize, even though it's always up and running and available for provisioning. So if we get a bit into the demo now, I would have liked to show you the demo real-time provisioning that's actually working well, but just in the interest of time, I took some screenshots of the platform to show you step by step some of the features. So let's get started with the web application side, right? This website is built on Vue.js. And actually, Vue.js is a set of static files, right? And this can be hosted on S3. So S3, if you remember before, is the object storage from AWS. You can also store static files in there and host a website. So it means you will only pay for the numbers of requests that you receive. And you can also cache all these requests and these files in Amazon Cloud Front CDN for so better performance and security. So at the moment, for example, the website is up and running all the time without server cost. So the platform is accessed securely through a Cognito sign-in. Cognito is a service that provides you this secure sign-up and sign-in capabilities, as well as access control. So basically, once you're logged in, all the API calls that we will make will be secure through GWT tokens that have been provided by Cognito. So from the device view, that's something you can see when you join the platform. Is basically all the devices that have been provisioned or that join the system manager inventory. And you can see the last deployment. I've been removing some information also, so just for you to know, the last deployment, also the connection status, if the machine is connected or not, a lot of different information. And as an administrator, you want also to probably upload and create some new playbook. So that's also something that is possible for you, a new playbook describing the set of software to install. And also, because we are using Ansible under the hood to provision these devices, we need some SSH credentials. And for this, you can also ingest some or upload some SSH keys, for example, that will be securely stored in the cloud, encrypted in a specific parameter store or secrets manager. And then, as we mentioned before, you can, as an administrator on this platform, create an activation that will basically say for this specific set of of tags, this specific factory, for example, I will be creating an activation, a license, more or less. You can even say for how many devices will be sharing this activation and in which region, and also you can manage the rights of this specific machine. And then you will have a QR code generated. Oh.
Sorry, are you done, or you're just trying to turn on another presentation?
Sorry, I think it's just the slide deck that just you should be able to see again, right?
Yeah.
All right, perfect. Was just the screen that got turned off. All right, so this activation, let me explain you how it actually worked under the hood in terms of architecture. So the users will be joining the platform, as I mentioned, the platform, the user interface hosted on S3. And then they will receive some Cognito GWT token, and they will send their request to API gateway. For example, in that case, when they want to create an activation, they will send a post request to API gateway that will trigger synchronously a Lambda function. And this Lambda function will first communicate with the system manager, a managed service, to create this activation. And it will generate a QR code that will be uploaded in S3. And all the metadata associated with this activation will be stored in Amazon DynamoDB. And all this is serverless. That's also one of the interesting points. And from the on-site operator's perspective, they will not do a post, but they will do a GET, right? They want to access the QR code. So they will be able to send a GET request to API gateway that will trigger another Lambda function. And this Lambda function will retrieve the QR code from Amazon S3. And from the mapping perspective, the mappings we mentioned, it's kind of this combination or this association between a list of tags for a specific set of devices, right, with playbook. And every time we will have QR code scan, we will try to see if there is a mapping found. So we will have a deployment that will be launched because we found a specific set of software to provision on this specific device. And then all the logs from Ansible and all the last status, the time, the cost of this deployment will be constantly sent from Ansible to CloudWatch. CloudWatch is a managed service from AWS that can receive your logs, your metrics, and create some alerts or create some dashboard as well. And then we will have a final status, right? In that case, we can see that it's a final status. We successfully provision an Apache web server. So let's see how it looks like in terms of architecture, right? You can see that we have the SSM agent running on the system on the system of the device on premise, and this SSM agent, the system manager agent, will be initiating a connection to the cloud whenever we have a new QR code scan by the team on site. So when we scan this QR code, we will send an event to system manager with all the set of tags and the information about the device. This information will then be pushed in a queue. If you remember at the beginning, Amazon simple queue service that will persist the data in a durable way. And this queue will be polled by an AWS Lambda. So really serverless, right? And this Lambda will have the role of checking if the set of tags that are coming from this queue are actually matching some of the mapping that have been created before by the administrator on the platform, as I showed you before. If there is a match, we will actually create a new deployment, a new post on the API gateway. And this API gateway on a new post will trigger a Lambda function that will do two things. The first thing, it will send a message on the event router in Amazon Event Bridge that will say something like, we need to schedule a new job for deployment. And on the other side, in the queue, we will persist this job with all the information necessary. The information necessary would be, we want to deploy this set of software in this specific machine that has these specific tags, for example. And Amazon Event Bridge, as I mentioned before, will also trigger and filter and route the message directly to the consumer. And in the case of a new job of provisioning being scheduled, the consumer is Fargate. So Fargate is this container serverless service that will be able to run your container image, for example, Docker, directly without managing the infrastructure. So you can see Fargate will be running an Ansible job, an Ansible task, that will be the one responsible for provisioning the device remotely. But this Ansible job needs some information about the device, which IP, as well as different information, for example, the set of software to provision. And If you remember before, so in the platform, the administrator had the chance to upload their SSH key that will be stored in the parameter store, as well as the playbooks that will be stored in S3, the YAML file that are the playbooks in S3. So the Docker image running Ansible will also fetch all this information. And then constantly on the provisioning, Ansible will share the logs to CloudWatch as well as the status, the last status to EventBridge. For example, it's in process, pending, or failed, or status completed. All this information are sent to EventBridge, and EventBridge, as an event router, will take the appropriate action. For example, updating the metadata in Amazon DynamoDB. And then we have a secure connection through a port forwarding and SSH tunneling directly from the Ansible to the SSM agent on the device. So let me now finish and conclude and summarize this presentation and the value mostly. If you think about this specific customer, Superfactory, as I named them, if you're trying to provision over a few months or even a few weeks, but let's take the few months again, instead of having all these servers up and running all the time, you have an automated platform that only launch resources when necessary. So you saw all this Lambda function, all this queuing system, of this event with EventBridge, everything is launched and triggered when there is a provisioning only. So as a result, you have a really low cost and cost optimized solution. Here you can see that the overall cost of this solution, if we take the assumptions of 3,000 deployment to provision for an Apache web server, that's really light provisioning of 1 minute 30 approximately. That would cost for the entire platform, right? The web hosting, everything around $10. If you to give you a bit of context here, $10, if you compare to running your servers for several months for the website, for the provisioning, for Ansible, that would be thousands of dollars or euros. There is also some more managed vendor solution that are also adding some licensing fees on top of that. So that could go up to $10,000s of dollars definitely for such solution. So if we summarize the benefits of this solution, you have a solution and a provisioning that is always available. From the moment you're manufacturing, from the moment you're shipping and provisioning, that can last for weeks or months, this will be event-driven architecture. So whenever you will scan the QR code, everything will be triggered automatically without a human interaction. Of course, you need before that to upload your set of software to install, but that's all. After that, it will be, if you want to provision something at 3 a.m., you can do it. It will be also secure, right? We'll be able to connect with a SSH tunneling from the cloud to a remote device. And you also have the possibility of having your keys and your databases all encrypted in the cloud, far from the end user. And this is, as we mentioned before, really cost optimized serverless architecture in that case, and also time optimized, right? You don't have to send someone, you don't have to have any manual task. And lastly, it's also integrating really well with the AWS integration, the AWS services. For example, CloudWatch services and metrics that we've seen before, but it could also integrate with more advanced features for analytics. There have been some analytics built on this specific platform, but in the interest of time, I just skipped it. But there is definitely some capabilities for data visualization if you want to build something more complex. All right, so we are coming to the end of this presentation. I hope that was interesting and useful. I hope you've seen what could be built as a serverless architecture, because we tend to see a lot of web application only, or some little tutorial, but there is actually a lot of really complex architecture that are being built by customers on AWS for a serverless workload and event-driven architecture. I just put here some links for, let's say, getting started on serverless. But please, you have my information here, LinkedIn, or also my email. So if you have any use case or any question, or if you want to share some feedbacks, please reach out to me. I'm more than happy to have a discussion with you.
Okay, thank you so much for your presentation. And before we go to Q&A session, I'd like to remind you that we have the career track and it's happening live right now. So you can see the direct link in comments and you can share it with your friends, colleagues, and go there because right now we have some speeches on cloud architecture there. So, yeah, and I also wanted to remind to all our community that Geekle is moving to a new format because starting from today, everyone can join our educational platform and to have the access to all recordings, including recordings from today's and tomorrow's. So please click the link in comments. I will send it right now, and you will be able to join our platform and stay tuned and see all recordings from all our events, both and upcoming. So, okay, thank you. Let's move to our Q&A session. I have some questions for you. I will create banners so you will be able to answer it. So let's start. Let's start with this one. What do you see as advantages in the serverless approach? What is the best way to convince my management to pursue this approach in layman terms?
So if we take the first part of this question, the advantages in the serverless approach, let's say the biggest advantage that you will see are probably the automation and the fact that you don't have to manage the servers, right? So you're saving not only cost, but also time. And you will be able to spend all this time as, for example, a DevOps or as a software engineer on the features that can differentiate your business and not on managing the scale of your server, the scaling of your server, for example. So that's really a business differentiator, serverless. It's this opportunity to work on what matters at the end. And based on the scenario, you can also have more or less benefits. Could be sometimes on the operational model, or sometimes it could be more on the cost. You can see on this specific use case, the cost was definitely the biggest advantage. Now, when it comes to convincing the management, there is a lot of different patterns that we can see through serverless adoption in AWS. And one of them is starting to experiment a bit, right? Starting to experiment a bit through, for example, small automation script. You can use, for example, Lambda to run some small script just to get started, get to know a bit Lambda, how a serverless Lambda function work, how to deploy a Lambda function, because that's of course a bit of learning at the beginning. So just seeing some benefits of small script for automation could be a good start, and then trying to extend it to, for example, a data analytics use case, and then later on maybe some web application or batch processing. You can do some ETL. There is really a lot of use cases. So I would say start with automation and then move it to something a bit more complex, such as data processing. And usually the management would see the benefits just by analyzing the cost or the automation or the effort saved. You might be able to convince them.
Okay, thank you so much. And we have, quite a related question. What is it going to be in the future for microservices with serverless?
Microservices for serverless. So I think something important to clarify here or to mention is actually Lambda. You can definitely see Lambda as also a microservice. Lambda is also executing one job. It's also something stateless that will benefit from asynchronous messaging in many cases. So that's also something you can consider as a microservice, right? You can run a microservice in Lambda. You can also run your microservices serverless with Fargate, as we mentioned. For example, in that case, Ansible was running on Fargate, which is also a serverless container service. So there is more and more capabilities for running your microservices workload with serverless. The good point is also that it's not only about the compute, but also the integration with the entire AWS environment. Because if you start talking about architecturing a microservices solution, you need to think how to externalize the data to make sure that your solution is stateless. And with AWS, you also have a lot of data store, databases, object store to externalize all this data. So I believe there will be a lot of there is already a lot of capabilities to run microservices on serverless and managed services.
Okay, thank you. And we have such an interesting question. Serverless in the future. Maybe you could share your thoughts on it.
Yeah, that's a good case, a good question. There is definitely one code that is interesting from Andy Jassy is saying that if Amazon would be starting now, they would be starting serverless for the architecture of Amazon.com. I believe there is a lot of big project and bigger project and big companies that are using serverless for production workload. If you know, for example, in the cloud industry, a cloud grew, that is an educational platform for learning cloud. There is a platform with a lot of traffic. I don't know how many users monthly, but it's a lot. And they are running fully serverless. So exactly on the type of architecture that I was mentioning before, through API gateway, through S3 hosting, Lambda function, queues with Amazon SQS, they are using this kind of architecture, and they can handle really high load. Because they can, at the end, just rely on the managed services to scale automatically. So that's definitely something, if you don't want to spend time on the infrastructure, that would be a great benefit for your business, and definitely benefits to differentiate your business from the competition. So yes, I can definitely tell you that serverless is definitely in the big picture for the future. There is few cases where, of course, moving to serverless architecture might be more work, more efforts at the beginning. So that's, of course, always to evaluate. But I would say that it's kind of, I don't want to say easy, but it's not so hard, right, to initiate a POC and to try serverless. Those are managed services. There is a lot of resources online. So you can also give it a try and only pay for what you use without commitment in terms of licensing, for example.
Okay, thank you. Another question. How practical is stateless in a true business environment where you need to make money from your Lambda service being called?
Okay. That is a really specific question here. You can actually also monetize your API gateways, let's say. There is also some possibilities on this. I would definitely suggest you to check online how to, for example, make the requester pay for an API gateway or requester pay for S3 objects. There is this kind of possibilities to also kind of create a business out of the data or the objects returned, right? That's definitely something possible.
Okay, let's go to the next question. It's more like, sorry, this one. Knowing what you know now, what would you have told yourself when you decided to become an architect? It's like more general question. Maybe you could give some advices, career advices to juniors or for those who just started their path.
So if we are talking about a transition from software engineering to architecture, that's exactly the path I took. I think it's a lot about curiosity, right? Every time you see a website, a solution, a specific challenge, always kind of, I mean, at least that's what pushes me for this transition, was always thinking, how is it working behind? How is it working under the hood? And I think that was definitely something that pushes me to learn more and more about distributed systems. I started to look at distributed systems that kind of bring me on the topics of distributed databases, distributed storage. Those are all topics that are covered when we talk about a large-scale application usually. As well as also advanced networking topics, how to handle latency globally. All those topics are also interesting when we are talking about architecture. And one of the important points as well is having some, or let's say an interest in building POCs or prototypes. That's also something that I kind of liked in my job at AWS, is also for some of my customer, demonstrating some of the capabilities. For example, someone was asking, about how to monetize a Lambda function solution. Building a POC to demonstrate such capabilities is always fun. So I would say that for an architect, one of the also good quality is also this curiosity combined with this ability to build, to demonstrate, and to experiment.
Okay, thank you. And I think the last question for today, how has the COVID-19 affected your work? It's such a popular question today for me because we all care about each other and we really want to know that our speakers are okay. So please share with us the information about the situation in your country. Is there a lockdown, or maybe you still visit in your office? How does it work?
In Germany, the situation, I wouldn't say the situation was too bad, I think, compared to other countries in Europe or in the world. So that was pretty fine. I got enough, let's say, work or activities on the side to keep myself busy, not to to get in a bad time. So I kind of got okay with this whole situation. Didn't go to the office. I can fortunately do all my job remotely without any issue. I think my customers are also fine doing our meetings virtually. So I can also, experiment, kind of study my architecture best practices on different technology remotely. So I wouldn't say I've been negatively impacted by the situation.
Okay, thank you so much. So I hope that everything will be okay, and very soon we will be able to meet each other, like our speakers and our audience, just personally. So thank you so much. Thank you for being with us, and have a nice day. Hope you enjoyed this time.
Thank you, Anna. Bye,
Okay.
bye everyone.
Bye.
Thanks you.
Okay, so before we are moving to our next speaker, I'd like to remind you that all recordings from our past and upcoming events will be available soon on our new educational platform. So you can join it today and get full access for 21 days for free. So don't miss this chance. I will send the link in comments, so you will be able to go there directly and simply see all recordings from this event too. So I think it's a good time to grab a cup of coffee, to maybe go around a little bit, because I will come back to you soon and we will be waiting for our next speaker. So see you soon and stay tuned. Okay, I'm back and I'm ready to introduce you our next speaker. And actually, it will be the last speaker for this track. Hi, Ashley. How are you doing?
I can't hear you.
Oh, you can hear me? That's weird, but maybe you could re-enter the broadcast studio. So
Okay, hang on. It's on my side. It's all right.
yeah, sure. We will be waiting for
Yes.
the.
There you go.
Oh yeah,
Sorry,
I
guys.
can hear myself. Okay.
Yeah, sorry. I can hear you. Yeah.
Oh, perfect. Okay, so Ashley Chamboko works for Group 42, and today he will tell us about architecting solutions for PoCs. I'm not sure if I'm pronouncing it in the right way, but okay, so you will tell us about proofs of concepts that work. Okay, so please, first of all, tell me how are you doing? How's your mood, and maybe how's the weather in your town?
I'm in Abu Dhabi right now in the United
Cool.
Arab Emirates. The weather is a little chilly today. We're actually in the winter. I didn't know the desert could be this cold. But it's been a lovely day. I've been expecting and getting ready to get started and present this course to you.
Okay, cool. So do you have a presentation, maybe some slides for your speech? You can share the screen, and yeah, I will add it to our main screen. So yeah, please, for our audience, don't forget that we will have all recordings from today's event on our new educational platform. So you have the link comments. Please join us. And yeah, we are waiting actually to connect the screen.
Okay. Should I also select share audio?
Maybe if you have some videos, I'm not sure.
Okay, let's see.
Yeah, let's try. Okay, so
let me share the entire screen.
yeah, you can share the entire screen, and then we will see all your information.
There you go.
Yeah, we got it. Okay, I'm adding to the screen. Now you can see your screen, and maybe you can show the presentation. Okay, perfect. It works. So I'm leaving you for 30 minutes, please. Good luck. You can start.
Okay. Good day, everyone. I hope you're all doing great wherever you are. So today I'll be presenting solutions architecting for a POC, proof of concept that actually works. Let's just jump right into it. Okay, we'll start off with a famous quote from one of great entrepreneurs in the world. They say that invention comes in many forms and at many scales. The most radical and transformative of inventions are often those that empower others to unleash their creativity, to pursue their dreams. So if you'd like to know who say these famous words, these inspirational words, we will review the emoji at the end of the presentation. Okay, welcome everyone. So the objective of this course is to define a proper POC, a proof of concept, and align a project around specific business impact, which requires planning and preparation, including research of the components that are needed and the requirements, especially the key requirements that are necessary for a POC, not necessarily developing a full-blown architecture, but only specifics that you would need to align. So these goals need to be properly defined. So you define clear goals and milestones for success criteria that prove capabilities and define the value of a POC. So if you do not set from the onset clear goals and milestones, it's going to be hard for you to actually track progress and actually see if there is any traction within the project that you're undertaking. So you need to execute your POC in an effective and efficient way. You need to properly plan your resources and whatever things that you need to know as a solutions architect you should gather your resources so that you don't prolong the time that is required for you to produce the prototype and also produce the final product, which would require you to pilot your MVP. And during that pilot, you'll be gathering information, data from the pilot project, so that you then better refine the product, or if you need to enhance more features of your product and fix the bugs, so to speak, any bugs that may exist within your product. So another thing you would also want to do is to shorten the time span that will be required for you to produce your MVP, your pilot, and overall your product to the market. So this can range from a couple of weeks to months. So what you would like effectively to do is to limit the time span to at least 60 to 90 days, so that within that time frame you gather the necessary matrix, you prove your case, you prove your product if it actually works, and you gather all that data and you analyze the data ready for launch. You also would probably be thinking about financing of your project, of the POC itself. Somebody has to pay for it, so you need to understand from the onset who is going to be funding the POC. And if we fund the POC, if it's a venture capital investor that's going to fund the project, or if it's a different partner or as an entrepreneur or the company for large enterprises, if there is a set budget for your POC to actually run. So I'm sure management and the business guys would probably need a way of you to justify the budget that they allocate for these kind of POCs. So in this discussion, we'll also talk about how to shorten the time span for you to develop a proper POC that has data and metrics, so that you can prove your case and then develop your MVP as a pilot and then as a final product within a short period of time. So this discussion is mainly aimed at startups. So if a startup would be, if you are an innovator, you have a brilliant idea, you can be a student, you can be an entrepreneur, or you can be an enterprise, small, medium, large. It doesn't matter what the case. All major products and all major inventions out there started as actual startups. So like the big organizations out there, they didn't start off as large enterprises. They started small, they started somewhere, and they started also as startups, but then they had leverage because they had a proper defined POC and an MVP that actually works, that enabled them to move on from being small to medium and to being a large enterprise. And some of them have gone on to be conglomerates. Let's go to the next slide. There we go. So most of these organizations like Facebook, Twitter, Amazon, Instagram, recently bought by Facebook, and Alibaba and Netflix, all of these organizations didn't start off as large organizations, conglomerates, big organizations, so to speak, but they all started off as a brilliant idea. So one day somebody had a brilliant idea. Jeff Bezos had a brilliant idea in his garage, and from there they started on with a proper POC that actually worked. And I'm sure if you probably follow the stories about that, he'll tell you that when he started off in the garage, it was only himself, and then a couple of friends later on, and then from there they refined the process, and eventually they started growing from stage to stage until the current stage where they are now, a proper conglomerate. So whatever idea that you may have, you may be a student, you may be an innovator, you may be a solutions architect, but this discussion can probably benefit you in one way or the other. Okay, so like I was saying, like most enterprises started off as startups. So being small and being an innovator with a brilliant idea, we would need somebody to invest in your POC that's properly defined with a proper time span, proper data and proper metrics. If you have your case proven, then it'll be easier for you to reach out to partners that can help you finance your POC and your MVP to be a full-blown product that can be supplied to everyone globally. So we also need venture capital companies that also require this kind of POCs, this kind of beta products that you produce out there with the backing that's needed, with the proper POC and data that's been gathered that can prove your case. A lot of VAs out there and partners, it can be Google partners, it can be AWS partners. They are there to especially help and encourage startups to build up their POCs and build up their projects to being medium to large enterprises. So in that example, there is an AWS partner network logo there, because I'm familiar more with AWS. AWS can give you POC credits. So if you're probably stressing about where you can get the funding to actually run your POC, or AWS can give you credits where you can actually use and consume those credits to run your POC. So usually POCs shouldn't exceed 90 days. So AWS can give you credits that can consume all the usage within your account, within your POC account for that particular time. So you need to get involved, especially if you're startups and if you're small. You need to get involved with the big guys. You need to get involved with the partners, get involved with the venture capitalists. So when you get involved, attend the webinars, attend the conferences, attend the seminars, attend the hackathons, the boot camps, and meet the venture capital leads. These are the account managers, people who have the ability to see your project through, to actually start the conversation of how they can actually assist you and leverage you to the next level. And you can also sign up for trials with services on AWS Cloud, on Google Cloud, on Azure. You can sign up for the free tier services. If your POC defines that, if it doesn't consume a lot of resources, if they are enough within a free trial environment, then you can go ahead and run your POC in that kind of free trial environment. And then you can further the discussion with your partners on how you can get more credits in the long term. So let's go. Okay, so as I probably define, the minimum time frame or the maximum time frame for you to actually run and develop this POC would be sometime around like 90 days. And within the 90 days, so that you don't have any delays, you need to set a proper milestone and target criteria, and also define what will be regarded as success. So there are a lot of, especially business partners who are less what can I say? Well, less more involved in the technical stuff. Usually want to add everything in there, including the kitchen sink. They want to dump everything in there. They want a full-blown environment. They want everything working from the PLC go. So you need to probably filter out those unnecessary things, and you need to sort of filter exactly what needs to be defined, define exactly what the criteria is to be considered a success, what kind of metrics you're gathering. Then once you have that, then you work from that point on. So in the POC days, you're specifically trying to validate the technical aspect of the environment, a simulation of what would be regarded as an actual product, but at a miniature scale. And then from the POC stage, we move on to the pilot stage, where you have a limited user base, and you need now user validation within that kind of space to gather extra metrics to top on what you already defined in the POC against what the feedback you're getting within the pilot phase from your customers. And then from that point on, once you're satisfied and you redefine your POC, redefine the product itself, then you move on to production. And when you move on into production, you don't just jump into production. there's a systematic way that you need to jump into production so that there is room for you to scale. There is room for you to automate the process, a room for you to expand on your product offering, at the same time get feedback from your customers and redefine the product to perfection. So as you can see, the number of days that you run through the whole process, from the POC to the pilot to the production phase, maximum there would be, well, in production, it can be inevitable, but the most critical point is from the evolution from your POC to a pilot. That's very important, because if you have a good POC, then the transition to pilot will be very smooth. But if you prolong the process of the POC, don't have properly defined technical aspects of the POC, then when you jump into the pilot, the product breaks or the product doesn't do as intended. And then the feedback that you get from customers before it's actually full blown is very negative, and chances of you getting an investor with the product that has failed in the pilot phase will be very difficult. So you need to get it right from the onset, so that on the next stage, in the pilot stage, when you get the data that's needed, leveraged and backed by actual user validation, then you can leverage that to get credits from your partners, from MVP, from venture capitalists, and from potential investors and entrepreneurs that can have confidence to invest in your business and your product. Okay, so from the idea phase, that's the first conversation that you start having as business people about your brilliant idea and what your idea would bring to the table, how it will add value to whatever offering that's out there. If it's a new service, how is it going to add value? How are people going to actually want to subscribe to your product? So we need to understand that. So there needs to be a business use case scenario that you need to properly define and back. And you may have an idea, but you need also a proper business use case so that you can properly work through your POC. So there's an evaluation and a decision-making phase where you gather around, you outline a mission statement on what's actually needed, you define the success criteria, discuss the funding criteria, discuss the pilot strategy, discuss security compliance that is actually required on paper in a single meeting before we actually move on to the actual fulfillment phase. So in the actual fulfillment phase, you define the roles and responsibilities. So you need to understand who is going to be handling what, so that you don't leave anything hanging about. So everyone has their own responsibility and their own timelines to fulfill the deadlines that are actually assigned to them. So you need to set milestones against your mission statement, against your success criteria, define the project plan, discuss your DevOps and automation processes. This is actually very important that you discuss the DevOps and automation process within your POC, so that when you now roll on from a POC to your pilot, and from pilot to production, everything has to be automated, because you don't want a lot of fingers in your production environment. So you need to define your DevOps strategies, how you're going to automate your code from your POC environment, automate that to your dev environment, then to your QA environment if you need it, then to your production environment. So you need to automate that and have proper DevOps best practices. You need to define your scalability criteria. Is there any integration that is required with existing services and offerings? That needs to be properly defined within the POCs. Because, for example, if we are trying to develop a sensor, an IoT sensor that's taking data from somewhere else, or it can be from people running in the streets, we want to measure how people are actually doing their workouts. So you might have like a smartwatch. So now we need to gather this matrix with the IoT device and get that to our database on the cloud. But now when we have it on the cloud, what kind of database are we going to use? And this database, how are we going to query this database? What kind of data are we going to need? Are we going to need business intelligence tools to run on it? Do we need logs on it? Do we need any kind of security on it? So this needs to be defined in the POC, because you don't want a product that instead of getting the amount of steps or kilometers that people have actually ran in the morning or in the afternoon, it becomes, well, it can get hacked, and people's data can end up out there on the internet and on the dark web. So you need to properly define that and have that in mind from the onset go. So once you discuss everything, once you have your strategies defined, your timelines defined, your responsibilities defined, you then put down white papers and you discuss your security compliances to make sure that your product will be compliant in time for pilot, in time for production. It needs to be compliant. It needs to have the necessary security. So a POC can have minimum security, but you need to consider any potential breaches. So you might have minimum security from the development phase, but the moment you start want to migrate it from a POC to an actual pilot, you need to redefine or rethink your security strategies and compliances. Okay, so the timelines, the goal here, you'll be able to lay out the key props that customers want in a product like yours and deliver measurable positive KPIs against value props against your POC. So as a general rule of thumb, I mentioned about the 90-day rule. So the 90-day rule should be enough for you to run a POC and gather all the KPIs that are required. So because of this possibility, it's a clear explained milestones before beginning the POC, so that you avoid a lot of confusion. So the goal here defines the what. So the what is setting hard and fast milestones in the first place, like as I defined. You need often to overlook the step. So people come with a lot of issues. Well, they want a lot of stuff in a POC. So it's up to you to filter out all the noise and probably define what's actually needed. So you set a measurable milestone, set your objective statement. So throughout the process, there may be any other surplus or that are irrelevant of the milestones. So you need to avoid all of that. You need to properly define what your success criteria is. So a well-run POC can be achieved for an overall greater than 80% close rate. So if anything that's greater than 80% close rate, anything that meets the criteria of your KPIs 80% greater is considered a success. Then potentially the close rate of you landing an MVP or you putting that to the pilot is higher. So the scope of the work and responsibilities is the who does what. So sales engineers need to be involved, and if there are any founders, then they need to also discuss with the business people that are involved in the business, so that you guys can properly have the necessary documentation down. Dialogue is needed within the parties to avoid any kind of confusion. So there has to be that constant communication between parties. Okay. Okay, so how do you monetize this? This is the why. So all businesses are out there to make profit. So if they are out there to make profit, so at the early stage, when you fully show the value of your product, you need to know and discuss at a business level how you guys are going to monetize your product. Is it going to be licensing, pledging, selling, or buying of the product, or litigation? You need to properly label clearly within the pilot that the price will be advertised, but not at the moment. This is a beta product, so that your customers know what to expect in the future when you actually launch. So the documentation, the first thing will be an NDA between all parties involved. If they're not of the organization, people outside third parties, your outsourcing sales engineers, you need to probably have NDA signed down. So if you are talking to a bigger company, with your prototype, make sure you have the documentation down, make sure everything is stamped and signed, your deliverables are, and the feedback documents are in line, and everyone knows what's expected of them. Okay, so you need to think security, compliance, data protection, detection, and infrastructure protection at all times from the onset go until you launch your product. Because any breach of your product in terms of security will render your product useless out there. People are very sensitive about their data privacy. So you need to think about your governance issues. You need to think about the risk and compliance involved with your MVP. So these are added features to the POC, but not necessarily involved in the POC. So as solutions architect, this will be more for the business guys. You mainly be concentrating on the POC itself, the groundwork, the implementation, research on the kind of product that you want to architect for. So how do you simplify the POC process? How do you shorten the time span for you to develop a proper POC and send it out there? So there is a product called Roof. It's called a POC as a service platform in conjunction with AWS Service Catalog. You can use Roof, launch in a different account and run your proof of concept from that account. Once that's deployed, you export that to the AWS catalog as an AWS product and then launch it from the AWS catalog. Okay, so that's what I've just defined. Okay, so I'm running short of time, so I'm just gonna browse through as a jet. Okay, so this is how the architecture looks like of Roof. So solutions architects out there and enterprises can use this application, this kind of environment. It's a set environment, software as a service platform, where you launch a template that will run your POC components and create a stack that you can then roll and deploy. For in this example, you have your DynamoDB and your EC2 instance where the Roof is running. Once your POC runs, it feeds all the data to CloudWatch Matrix, which in turn produces your KPIs, where the POC owners, which are the business owners, can have a look and have a properly defined document that have the necessary matrix to prove their POC to be a success. So once you have that working and running, everybody's happy, then you want now to export that to AWS as a template. Once you get that in the portfolio, in the AWS Service Catalog, in the AWS portfolio, you will then roll that deployment from the template into your own AWS account. So it can be deployed into a dev environment where you can quickly test it out. If everything checks out, then you can either decide to roll it from your dev account to your QA or straight to your production account. Okay, so this is the kind of data matrix that you would get from running Roof. So basically, in this example, we're actually getting DynamoDB matrix of analytics and simulations running on the EC2, and then that's later on fed on to our EC2 instance dashboard through CloudWatch Matrix. So in this case, we have your live metrics and the simulations. So all this information will be very vital to prove your case to be a success. So you export the environment. Once you're happy, you connect to the service, you deploy that, you export it to AWS. Once you export it to AWS, it lands into your account under the AWS portfolios, service catalog. Then you deploy the portfolio, and you deploy it as a product. And during all of this transition in Roof, you do have a dashboard that actually tells you the progression of your POC. So not everyone else keeps coming back and there's uncertainty on where the project is. So people can know and have set timelines to see if they are breaching the timelines. So the moment they actually join the POC, the preparation, execution, and evaluation phase, and the final approval. So everything is tracked in real time. So an example of a customer that I've dealt with, this is a customer called Digital Biosystems. This company is a medical concern that's doing augmented intelligence for precision medicine. Started off as a POC, properly defined milestones. They developed and they rolled out their POC into a pilot product, and now they're in full production on AWS. Great project that was. So make sure all the time when you build or when you think of building or architecting a solution, build for failure, automate everything and prioritize your security, because that's going to help you in the long term. If you have this properly defined pipeline of how you build, you test and release from the POC level to your pilot level, everything should be automated. Everything should be running with your DevOps best practices. So basically from your infrastructure, you deploy your infrastructure as code, deploy your application in your code using AWS code pipeline to properly deploy your applications in your code to your instances or to your end users. So basically your account structure from your POC would be to a dev environment and to a QA environment, properly test your product. Once everyone is happy, then they export that to the production environment. Voila, and then you deploy a new product and congratulations, your product is launched. And I think my time is up now. I'll be ready to answer any kind of questions that you may have. And I'll tell you the famous quote at the end of this presentation.
Okay, so thank you so much. And can I please remove your presentation? Yeah, just for this time. And before we start, I'd like to make a little announcement, because as you all know, we will have a QA Global Summit in March, and we'd love to see you among us. So please join us, and you'll get 2 days and 14 hours to learn how to build QA from scratch, and which mistakes to avoid, and how AI can improve testing experience. So right now you have the possibility to buy your ticket just for $30. Please don't miss it. I will leave a link in comments, so you will be able just to go there directly and book your place. Okay, so now we are moving to QA panel or session, how you prefer. I have some questions for you. I prepared it. So I will show you banners. The first one, what are the best practices to protect my data against attacks in every layer? I'm not sure if this question is related to your topic, but maybe if you know the answer, we could discuss it.
Yeah, so there are security measures that you can take at every level of your architecture, from your infrastructure stage to your application and your software. There are different techniques that you can harden your product. It can be a product, it can be code. There are strategies that are specifically built around that, best practices that you need to abide by. So once you have these and competencies, AWS call them AWS competencies, where these security competencies, like your ISO 9001, ISO 9000, they need to be properly in place, so that when auditors come in to fault-proof your application, for example, in AWS, you actually submit a proposal to AWS, and AWS sends an auditor to come and audit your environment for any potential leaks, anything that is outside of best practices and well architected. Then once they detect that, they'll give you recommendations on how you can fix that, so that you know what's actually needed to fault-proof your whole environment, from your code to your infrastructure to the end product. It can be a service, it can be an actual hardware device. As long as it's connected to cloud, it needs to meet specific best practices in terms of security. Excuse me.
Okay, thank you so much. And the next question, should security be managed at each individual service or have a single centerpiece?
Security should have a security center of excellence, where you would have your security team, a specifically defined team that handles your security at all levels. So this specific group should have raised privileges throughout your architecture. They need to properly define the specific individual roles. So for example, if you have a salesperson and you have a developer working on the same account, a developer needs to be able to do what a salesperson needs not to have any access to, because they might delete code that they don't know is code. So they need to be as a properly defined set of privileges. So in AWS, there are IAM users and IAM permissions that you can define per user. So a sales group can have all the salespeople, and they have the same kind of privileges on an account, where as a dev group can have only access to the dev component of the same architecture, but not have access to sales spreadsheets and budget papers, things like that.
Okay, thank you. And the last question, I can see the link you mentioned about the testing and AI. Could you share it? Maybe it's possible or not. We can
mention about the testing and AI. You can mention it. Okay, so that was the link about the example that I gave at the end. So that's an example of a customer I worked with to deploy their POC and moved on from POC to pilot, and now they're in production on AWS. So they're using a software called Roof. So Roof, okay, I'll share that link in the description. So what Roof does enables an enterprise. It can be small, it can be medium, it can be large. If you're a large enterprise, then this is a good tool to actually use, because you have a team that runs your POC. You give your team access to this tool to run different POCs. Like for example, it might be Apple or Huawei. They will probably have this tool developing in different teams. I mean, there'll be a different team for each different component for their whole suite. So each team have access to this tool to run their own separate POCs at the same time. And you can have a central place where you can monitor each POC and what everyone is doing in the organization and where you are within the transition POCs. So it's a great tool to have. I'll probably share that in the link right now.
Yeah, you can share it in comments. You probably have the access to this chat. So, okay, thank you so much. Yeah, I think it was the last question for today. Thank you for being with us. I hope that you enjoyed this little journey with Geekle. So, yeah.
I'm sure people are waiting to see who actually say those famous words at the beginning of the presentation. So let me just quickly share my screen quickly. So
yeah, sure. Do it right now.
People can see who it was. And
okay.
I didn't see people didn't even attempt to recognize the person.
Sorry, like, yeah, just try to share. Oh, yeah, I got it. Okay, I think I should disappear from the screen and now you can finish your presentation, okay?
Cool, so let me quickly get, there you go. Jeff Bezos said those famous words: invention comes in many forms and at many scales. The most radical and transformative of inventions are often those that empower others to unleash their creativity to pursue their dreams. Great quote. The end. There we go.
Okay, thank you so much. It was really good. Okay, so yeah, thank you so much. Okay, yeah, I see you shared the link. I should send it to the comment chat. So please, here's the link that we've mentioned before. Thank you so much. So hope to see you on our next event and have a nice day.
Thank you. Cheers.
Okay, so it was the last speaker for our track today, and I also wanted to remind you that now you can purchase a ticket to our QA Global Summit just for $30. You can see the link in comments. I will share it once again. So please don't miss the opportunity to be among first attendees on our QA Global Summit. So what's next? Well, as you remember, we were telling about a little challenge with social medias, and now I'm ready to show you our winner. So let me share my screen. I will choose Instagram. So, as you see, we have Sergey Dergatsev, if I'm not mistaken, and his post is really one of the best. And now you can see him. Maybe you'd like to follow him and be up to date. So, thank you so much, Sergey, for your post. We really loved it, and hope to see you on our next events. Okay. And now I should disappear from the screen just for the moment, and then I will come back to you with Anna, and we will announce the winners of our another challenge with free tickets for our next events. So wait just for 1 minute. So we are back together with Anna.
Yeah, hi, and thank you so much for being with us today on this vendor track. As we received really many feedback from our attendees, and I'm so happy you loved this track with our speakers. So, and now I'm happy to announce that we are ready to find our 5 lucky winners for the questions. And you have opportunity to get the ticket for the upcoming event by Geekle at choice. So please, Anna, share the screen.
Yeah, let's do it together. Let's choose this tab. Okay, now you see all names from those who left their comments. And what should we press? Randomize, right?
Yeah, so here we have all our active attendees who asked questions and were really active during the event. So currently, like right now, we are going to randomly choose 5 winners, 5 of these people.
Okay, are you ready?
Yeah, I'm ready.
Let's do this. Okay, we have 5 people here like this. Let's copy that, and we will go back to our chat, and we will leave these names here. All right?
Yeah, exactly. So we we would happy to congratulate you with this win, and you are really great and awesome. Thank you so much for your questions. Thank you so much for being active. Actually, if you're currently watching us, please leave your feedback in the comments and we will contact you back. Or you may find our dedicated specialist's email. Her name is Mila. Please email us and we will provide you with tickets. Yeah, thank you so much.
Okay, thank you so much for being with us. I think it's time to end up this track for today, and we really hope to see you on our educational platform. So please don't forget to subscribe and to see all videos from our past and upcoming events.
Yeah, and please don't forget that tomorrow we will have the second day of our Worldwide Software Architecture Summit. So please join us. We'll be waiting for you.
Yeah, thank you so much and have a great day.
Bye-bye.